გამარჯობათ, მოგესალმებით. ეს არის DevOps კონფერენცია, რომელიც უკვე საერთაშორისოა. მესამე კონფერენციას ვატარებ, სადაც ყავს უამრავი საერთაშორისო სტუმარი. შესაბამისად, მოიწევს გადართვა ინგლისურ ენაზე. So dear all, first of all, thank you very much for coming on Saturday in this horrible traffic. But I hope you will enjoy today's session. We have very interesting speakers. And I would like to say a few words about this event. So this is a DevOps Con Tbilisi 2022, third event in this series. This conference is completely international. So previous two conferences we had in Georgian language. Speakers were also conducting everything in Georgian. So now everything will be international English. So a more broader audience will understand what is going on here and what we are trying to achieve in terms of community building. So I would like to thank to Ilyas State University, the host of this event. They provided lots of support and help in organizing all this, so thank you very much. We are also very grateful to our general sponsors, Data Art Georgia and Bank of Georgia. Representative of Bank of Georgia and as well as co-founder of DevOps Georgia will speak a little bit more about this. So one thing that I would like to admit here, so that the purpose and the goal, one of the main goals of this conference is to support Ukraine in this war because we have lots of colleagues, lots of our well-known friends work there, they live there, they suffer from this, and we could help and support them with this conference, with this event, and by increasing awareness about how you can support them in this unjust war. So I would like to give stage to Vaja, co-founder of DevOps Georgia. Please go ahead.
Hello everybody again. Thanks for coming. So as Erekle already mentioned, our primary and main goal is to build a community around DevOps, around technology, and basically this is why we are here. So most interesting part happens after the conference, like during a lunch break. So I advise you to actually go ahead and speak to the speakers, ask them questions. So basically, don't be shy. And actually, I also would like to mention that we are supporting Ukraine. So there is U20 fund, which helps Ukraine. So tomorrow we will have Ministry of Digital Transformation from Ukraine. So basically, I would like to again mention that we support Ukraine, and we would like to actually raise the awareness of U24 fund. And basically, that's it from my part, and probably Nino will have the stage. Thank you.
Thank you, everyone. So we would like to invite Rector of Ilyas State University, Nino Borkinidze, please, for the welcome speech.
Good morning, dear guests, dear colleagues and students. First of all, I would like I'm very pleased to welcome you on behalf of Ilyas State University, and thank you very much for joining us today and for making this this conference possible. It's a great pleasure for us to host it. My special thanks go to our dear guests, sponsors, and partners, organizers. First of all, dear Ukrainian colleagues, the representatives from the Ministry of Digital Transformation of Ukraine, the U24 Foundation. Thank you very much for your great job, for your civil position, and for your heroism. Your achievements have already shown us the real power of technology-based education, real power of dignity, and real power of post-Soviet democracy, young democracy against post-Soviet authoritarianism. Yes, the recent war unfolding in Ukraine and events in our region or worldwide is a bitter confrontation between young post-Soviet democracies like Ukraine, Georgia, Moldova, and the post-Soviet authoritarianism. This prolonged confrontation, it was earlier in 19th in Georgia and in 2008, also in Georgia, in 2014, Ukraine, Moldova, has clearly shown us the vital importance of directing all our efforts towards empowering technology-based education and research, and on the one hand, and towards empowering democratic institutions, academic institutions created amid post-Soviet modernization processes on the one hand. On the other. Ilia State University is one of them, and we see its role in a broader regional context. So just a few words about the importance of this conference and of technology-based education and science in general, which is one of the main priorities of this university. In 2018, Professor of Digital Humanities at Northwestern University, Ro Parisam, published a very interesting book, New Digital World, Post-Colonial Digital Sciences in Theory, Praxis, and Pedagogy. This book has already aroused very intensive discussion in several fields, including social and political sciences. The main questions that the author tries to answer in this book is about the relations between power, technology, and social justice in the modern digital world. Namely, they are discussed technology and digital transformation as a key element, as a key opportunities for justice and equality for post-colonial, including post-Soviet countries. As one of the biggest perspectives for post-colonial and post-Soviet societies. We belong also to them. I think the Ministry of Digital Transformation of Ukraine and the U24 Foundation have already shown the power of these discussions, or this ministry is a best practice or is a best example of these theoretical discussions. I would like to take the opportunity to thank the organizers, supporters, and donors of this conference, Professor of Ilia State University, Bank of Georgia, and the software development company Data Art. Thank you very much for your effort.
So our next speaker, thank you very much for your words. This is really important to admit. Basically the motto of this conference. We would also like to thank to all our sponsors like Mთავარი Georgia, IPAM Georgia, and all our supporters. So now I would like to invite Vaja Mantua on stage. Vaja, where are you? Here you are. Great.
Hello, I am Vaja Mantua, Deputy CIO at the Bank of Georgia. And before starting the conference, before starting my talk, thanks a lot to Vaja indirectly and DevOps Georgia community for such amazing event. Today I'm talking about the technology company, why the technology company is so important in modern era, and why the Bank of Georgia, the leading financial institute, is a technology company. So let me share some information regarding the Bank of Georgia. Bank of Georgia is most trusted bank and top of mind bank in Georgia. You see that in the market share, we are leading in the payment transaction, we are leading in the deposits, and one of the leading in the loan individual market share. And it's a very important point that we have the outstanding profitability in the first half of year. In this year, it's about the $500 million lari, and I think it's a very, very good point and good KPI for the financial organization. And then another very important KPI which see the health of financial organization is return for average equity, and we have more than 31% in first half of the year. So behind this number is, I think, the two main points to be successfully. The first of all is to be the customer-oriented company. What does it mean to be the customer-oriented company? Customer-oriented company means that you should listen to the voice of your customers. You should be there where your customers are. You should gather a lot of statistics, a lot of information for the customer behavior and try to fit the behavior of the customer. It's a baseline of the success. There are very important KPI, Net Promotion Score, as known as NPS, and we was calculated this parameter, and this parameter show how the organization is customer-oriented. There are very big challenges for the financial institutes to increase the number of these KPI, and you can compare, for example, now our KPIs, what is our NPS, what is NPS, so well-known financial organization, or even the technology companies. We are using cloud platforms, Salesforce and Medallia, for collecting the customer needs, for analyzing customer experience, and to calculate happiness of our customer. So I strongly believe that the baseline of the success is to be the customer-oriented company, but it is not only one part. I think that there are a very small part of company which can change behavior of the customer. Because one point is that you can fit behavior of the customer. But another point is to change the behavior of the customer itself, and it's a very difficult task. And there are a lot of small part of company which can achieve this. And if you achieve this, your profitability, your goodwill will increase 10, 4, 5 times. I believe that the Bank of Georgia is a game changer in the local market and not in the local market, and I will try to describe why. To make changes, changing the customer behavior, you should be the technology company. There are very interesting parameters. It's a ratio of the daily active users and monthly active users ratio, which show us how often our application is using with our customers. You can see that, for example, for the one particular application for our digital mobile banking, we have 1 million monthly active users, and approximately half of them are using it in daily basis. If you compare it, for example, the social network applications, such like Facebook, Instagram, or WhatsApp, we see that the Bank of Georgia is not far away from them. Sometimes he's a winner. So we provide one of the most daily active user application in Georgia, with 91% of customer satisfaction ratio and with 90.9 service availability. So I think that the point that we can change behavior of the customer is a key point for the success. Inside the success, I will describe why we're thinking that we are a technology company. We will provide software development. We have the software development inside our organization, and we create software inside our organization. Core banking platform, mobile banking platform, internet banking platform, API marketplace, internal platforms. We will develop ourselves. We are provider for our developers, a platform provider, because IT operation also are inside the organization. We have the certified data center. We have a strong SLA. We are a platform provider. We provide cloud infrastructure and automation. Another point is, and very important point, is that in the Bank of Georgia, we were starting to use data and machine learning for the financial offering and for serving the data. We have the big data ecosystem. We are actively using machine learning, model training, data platforms to serving the data, serving the customer data, because we believe that the best assets for the company is the people who are working in the company and the data, and data is restored in the company data centers. Let me share more details about our teams, about the people. The Bank of Georgia has more than 700 tech employees. And we starting to use, for example, feedback culture. Feedback culture means that we starting to thinking about our problems. We define our problems, and we starting to work to challenge, to defeat these problems and somehow resolve it. Another part is independency. We changed the structure of our IT department, and now we have more than 80 dedicated cross-functionality squads which are responsible for particular product or particular platform. And we give them independency. It means that every team can organize and plan work itself. Independence is very important to increase engagement of the employee and to share the organization goals. Another main point is, I think, the safety, because we try to create safety environment for our employees. We believe that the safety is very important for the human, and we're thinking that if the human feels safe inside the organization, it can somehow defeat threats from outside organizations. That's why we try to create very safely and human rights, based on human rights and human and employee centric culture into organization. We're starting to use a career path and personal development life cycles to show our employees how they can achieve more goals and achieve more results. It's very important to create and define the processes inside the organization, because it's a mandatory part for the success. We are using Scrum, Kanban, onboarding process, mentoring process, internal training process, ITL, CMMI, and DevOps processes as well. We are using, we try to create a very flexible environment for our employees. Be honest, it's not an easy job, because the financial organization has a lot of regulations, a lot of security concerns, but we try to find somehow solution which can somehow cover the security tasks and also have the flexibility environment for our employees to create software and platforms. We are using cloud platforms, collaboration tools, virtual desktop infrastructure for our employees to give them the best platform to the working. So I think also it's very important to define the KPIs, because when you define the KPIs and KPIs is measurable, the goal is clear, and the all of organization is going to this goal. We are using technology KPIs, not for the inside the IT department, for the all of bank. So, for example, we have such kind of KPIs for service availability, resolution time, cycle time, lead time, ENPS. ENPS is very interesting KPI. It's measurable for our employees' happiness, turnover ratio, audit index, and number of vulnerabilities. Another main point, I think, is that you should define the shared KPIs, which is very important inside the big organization, because there are a lot of departments which has his own goals, and it's very important to make alignment between the directions, and the best way to achieve this is create shared KPIs. For example, my shared KPI is customer CSAT of the mobile banking. I am responsible for IT operation, and I am not involved, for example, to create customer journey in our mobile application or create particular feature, but I share this responsibility and this KPI with our digital channels, the digital channels department, and it's very important to have the shared KPIs and make alignment within the organization. Let me tell about small things about our core project. The one of the biggest project is microservices and Kubernetes, which means that we're starting to move our platform from standard monolithic architecture to the modern microservice architecture, and my teammates will tell about more about this project. Another big project is cloud adoption. So Bank of Georgia was announced that after the 5 years, the Bank of Georgia will be full cloud-based organization, and all of our platforms will be the public cloud. Now we are working with one of the world-known company, Rackspace, to create cloud adoption strategy and to create cloud migration framework for the large organization. Because for enterprise organization, it's not an easy job to starting to migrate from all of infrastructure for the on-premise data centers to the public cloud. So it's a very big project, and we are working about it. Elasticsearch, connected core and notification services is one of the part of our services which we create, project which we created for migrate to the microservice architecture, which is more scalability, performance, and easy administration for the Bank of Georgia technology team. Cloud is cloud give us them a lot of benefits. For example, scalability, performance, measurable SLAs, and what's very important, instant access of the computing nodes. It's very important when you see that technologies grow up, and you see that, for example, monthly active users was increased 2-3 times within 3 or 4 years. So it's very important to have instant access of the computing node as soon as possible. Today we are in the DevOps conference, and I will describe the why is DevOps so important. My speech is not technology speech. That's why I try to say why the DevOps is important. For me, DevOps is not just a tool. DevOps is not just a process. I think that DevOps is a mindset of success and future, and I will try to describe why. When you invest in the DevOps direction and are using the DevOps platforms, you have the different mindset. It means that you're starting to thinking about the reduce of the lead time of the feature. It means that you starting to see to reduce of cost. It means that you start to think to increase the quality, increase the testing processes, increase the monitoring processes and alerting processing, make some processes automations, some process automations, because DevOps itself is somehow another technology company within the technology company. If you see that why the technology and IT become so important, because they are starting to make automation of the business processes. Now DevOps is starting to automation of the technology processes, because technology processes become the business. And that's why if you see that what the mindset of the success and mindset of the DevOps is the technology and the customer centric. Sorry, the presentation was in another computer. There are some mistakes. So that's why the DevOps is, as I said, the mindset of success and future, and it's not just a tool, it's not just a platform, it's a culture. It's a culture, it's very important to be a success. Let me share information about our DevOps team in the Bank of Georgia. I'm proud that I am a teammate of such kind amazing team. I believe that this team is one of the best team in the region. And if you see the numbers, we're starting for the very simple administration for the collaboration tools, create some very simple CI/CD pipelines and some start to administration the GitLab platform, but time after time we increase the platforms and the services in the DevOps portfolio. Now DevOps has a very large and very important portfolio for the Bank of Georgia technology stack. We are using Kubernetes, Redis in-memory database, NiFi, Kafka, Terraform for the infrastructure as a service platform, Tosca for automation testing platform, Dockers, containers, centralized logging tool, GitOps platforms, and GitOps practices. We, in DevOps team, we have ownership for the application monitoring tool Dynatrace, for the Grafana, open sourcing monitoring tools, Grafana, Prometheus, etc. So now the DevOps team in the Georgia are managed with we manage a lot of very interesting and modern based on microservices architecture platforms. What is the future of the IT operation? There are two main points. One of them is the cloud, which I already mentioned. We are going to create cloud management office inside the organization who will be responsible for the migration of the public cloud. We create new roles, responsibilities for the cloud architecture and cloud platforms. And another topic is the DataOps practices. So Bank of Georgia has a very large department outside the IT department. It's the data department, which are creating the data pipelines, as I said, to create them using the big data appliance and big data platforms to manage the data and serve the data to the customer. Now we are starting to create operation model for the data department, and we create DataOps direction into the DevOps and DataOps direction. Let me share some flow, how we are using the data flow and why DataOps is so important for organization. As I said, the data is one of the biggest assets for the organization because you know everything about the behavior of the customer and can offer customer-based specific offers, and it helps to make some financial decision and so on. We have a lot of data platforms inside the organization, starting from the standard relation databases, Oracle databases, modern databases, Mongo databases, Elastic databases, Postgre databases, even standard file system. We take the data from such kind of data sources. We're starting to preparation the data and store in another big data ecosystem. For example, such kind of ecosystem is Hadoop and Hive. We're starting to transformation this data to make this data more visible and more servable. And after that, we published it in the feature stores. And when you have the data features in the feature store, our data analytics and our data sciencing starting to using machine learning, AI to model training and model serving to create service as a data. And now we have a very interesting open vacancies regarding DataOps engineer also. I think that the DevOps and DataOps is a very different direction, but they have the very same flow and same mindset. There are only different platforms because the development life cycle and data pipeline are using the different platforms. That's all. That's all. I'm finished. The last point is that we have a lot of vacancies in Bank of Georgia team. I believe that we have the one of the best technology team in the region, the largest region with the largest platforms, frameworks and tools. And if you have the chance and opportunity, welcome. We are here and we will listen to you. Let me speak in the Georgia. So, ვისაც გაქვთ სურვილი მოკლედ რომ იყოთ საქართველოს ბანკის წევრები და გაქვთ სურვილი რომ იყოთ ჩვენ ტექნოლოგიური გუნდის წევრი, მოკლედ აქ ვართ ჩვენ დღეს მთელი დღის განმავლობაში, მზად ვართ გაგესაუბროთ და მოვისმინოთ თქვენი შემოთავაზებები. Thanks a lot. Thanks a lot.
Thank you, Vaja, for your interesting talk. And now I would like to invite on stage Becca, and actually he will talk more about how we started our transformation from monolithic infrastructure to Kubernetes, and also he will share what technology stack we have and what we are using exactly.
Hello. Hello everyone. I'm Becca, DevOps engineer from Bank of Georgia. Today, me and Gio will talk about DevOps transformation at BOG. So we will talk about challenges we faced with monolith, how transfer process passed, what tool sets are we using for everyday our duties. So how we are doing provisioning process, about our infrastructure architecture. Also, we will make quick overview Rancher user interface, what options do we have and what benefits do we have, how we are tracing and monitoring our applications, how we are doing our CI/CD processes, and we will cover also security topics. So a large monolithic application makes development more complex and slower indeed. So also you have to do some manual jobs regarding scalability. And if there is an issue in any module, it could affect the entire application. Indeed, you have also lack of flexibility as monolith is constrained by technologies itself. So deployment process is uncomfortable as small changes to a monolithic application requires the redeployment of entire monolith. So why we choose microservices? So with microservice you have frequent and faster release cycles indeed. You are flexible with scaling. If a microservice reaches its load capacity, it will be scaled automatically, or if demand or request decreased, it will be downscaled automatically. Also, you can deploy changes for a specific service without redeployment entire application. So also microservice architecture allows teams to be free to select their desired tools, and developers are more happier as they are more autonomous and can build and deploy themselves applications. So transformation process started. Developers started to divide large application into microservices, and we started containerization of microservices and built HA infrastructure for container deployments. So when we are talking about containers and container orchestration, we mostly considering Docker and Kubernetes, as they are common technologies on this regard and have a large community. So then we started researching enterprise Kubernetes providers, and our main requirement was support from providers. Also multi-DC on-premise Kubernetes cluster, as we'd like to deploy active-active architecture. Integration with vCenter was mandatory, as our infrastructure runs on top of VMware. Also, integration with various cloud providers was important, as in our roadmap is some cloud adoption, as Vaja mentioned. Integration with Active Directory and flexible tools for cluster backup and restore processes. So then we passed testing scenarios with various Kubernetes providers, and finally we choose Rancher. Before we start discussing about architecture, let's talk about our tool sets. The first one is VMware. As I mentioned, our infrastructure runs on top of VMware. So for CI/CD processes, we have Jenkins, and for source control, we have GitLab. Also, we are tracing our application with Dynatrace, making load balancing with HA proxy, and as ingress controller in our cluster, we are using Nginx. So we are doing monitoring with Grafana, Prometheus plus Alert Manager stack. We are doing our Kubernetes deployments with Helm. We are using ElasticDB for application logs. Cilium is our CNI. And for secret management, we are using HashiCorp Vault. JFrog is our private repository, and Red Hat is our main guest OS. We also are using Istio Service Mesh for some namespaces in our cluster, and we are doing our provisioning process with Terraform. So on a slide is presented provisioning process. As I said, we are using Terraform. We have defined all needed resources in Terraform script. In our case, Wispera is provider, and we just deploying our code. And let's talk more about what processes goes after Terraform deploy. In VMware we have VM template, Red Hat based, including Docker package and Cloud Init package. So Rancher API requests VMware to clone VM from template, and cloning processes go on, and after VM is up and running, Rancher sends Cloud Init configuration, and on a VM started process to set up Kubernetes cluster. So after we get Kubernetes up and running, so we have to do some manipulation on the VMware side, as we have multi-DC architecture. Nodes are distributed across the ESXi hosts, and Affinity rule helps us to keep balancing between data centers. In case of failover, data centers, we are safe from troubles. So this is how our Affinity rule looks. We have VM groups and host groups, including desired VMs, and DC. We have defined that DC1 VMs, for instance, should run on hosts DC1 hosts group. So let's talk about Cilium. It's a flexible CNI, as you have create flexible network policies, DNS-based of IP-based access lists. With Hubble dashboard, you have transparency of network activities. It has great community support, and as load balancing works through eBGPF throughput is improved instead of QProxy. On a slide is shown some result. As you see, when you have more than 1,000 service deployed in cluster, eBPF result is better than IP tables. So next topic is how we are doing network policy management. Per namespace, we have deployed default deny policy. As you see, we have restricted ingress and egress traffic. Only kubedns traffic is permitted. On the right side is our custom policy, and you can see that we have permitted ingress traffic from ingress Nginx, and we have egress traffic permitted to proxy app POG on a HTTPS port, as you see, and some IP address we also have permitted. So this is how Hubble dashboard looks. As you see, we have possibility to check what traffic goes per namespace. As you see, there are shown verdicts. Some packages are dropped by network policy, and some ones are permitted. So, as I mentioned, we are using Nginx ingress controller, as it is supported by Rancher, has great community support. In our case, we are deployed, Nginx is deployed as a time offset with host network through configuration. That means that HTTP and HTTPS ports are listening on Nginx on worker nodes. So we need load balancing on front of Nginx controller, and we are using HA proxy. Actually, clients connected first on HA proxy, and HA proxy sends traffic to ingress controllers. So, concern with on-premise is that you can deploy service-tied load balancer out of the box. You can achieve this stuff with Metal LB, and you can create load balancing inside cluster. So Metal LB works on layer 2 and layer 3 mode. Also, as you see, BGP supported. It's easy to deploy and manage. Let's talk about persistent volumes. Mostly in our cluster we are using stateless applications, but some applications, for some applications we need persistent. So as Rancher and VMware has great connectivity integration, you need just to deploy storage class, indicate data store from VMware, and then you can deploy persistent volume claim, desired amount of storage, indicate storage name from which data store we would like to create VMDK, or just you can deploy your stateful application, and after a while it will be up and running. So the next topic is how we are managing backup and restore. It's CD snapshots. We are doing manually or automatically with IRCAI tool. You can create some retention policy. You can ship created snapshots to S3 compatible storage out of the box. This functional comes, and also restore process works with IRCAI tool. So then let's make a quick overview of basics how secret management with Vault works. So we have deployed Vault on our cluster, and first step is when developer puts secrets in Vault. Second step, when service account tries to authenticate on Vault to get desired secrets from Vault. Z Vault verifies a service account, and after validation process, it sends secrets to a pod. So that's all from my side. Gio will continue presentation. Thank you.
Hello, guys. I will continue our presentation, and let's. Sorry. Okay. As you see, we choose Rancher for management our Kubernetes. At the moment, we have 100 deployments in Kubernetes production cluster, and 400 pods are running in our cluster. Kubernetes is promoted for zero downtime updates of deployed applications. In other words, it means that application will not be interrupted by update, and it will continue processes requests without downtime. Rancher benefit is to have marketplace to manage repository, Helm chart repository, and installed applications. Also, you can manage your cluster, cloud cluster, beside of on-prem cluster in one Rancher. In this slide, you can see a deployment YAML file with rolling update strategy. Our releases are more smooth, and as I don't remember Becca is mentioned or not, but we run our Kubernetes into that two data sets, and with topology awareness, Kubernetes redistribute pods across these zones, and if we have some disaster and one DC will go down, our applications will continue work in the same workload as before. In this slide, we have some example deployment, and I try to explain how deployment phase is going. Let's see in first picture, we have application version 1 with 2 pods. We have some features in version 2, and we want it to deploy it. When deploying process start, pod with version 2 create, after pod when get ready status, one of pod with version 1 will determinate automatically, and this process will go on, say multiple times, depend on how many pods we have. Also in deployment YAML file, we must indicate resources of pod, request resources and limit resources. Also, we must indicate replica sets. At this moment, we have 3 replicas, 3 pods. After deployment finished, we will have 3 pods running. Also, Kubernetes have auto-scaling function. That means that Kubernetes itself decide how many pods must be run based on resource monitoring. At this moment in slide and this picture, we see that we have 1 minimum pod replicas, and maximum replicas is 3. Kubernetes have also self-healing functions. That means that if some happens and pod crash or application do not respond to our health check, pod will restart automatically. For application log, we have a logging stack with FileBit, Elasticsearch, and Kibana combination. FileBit get all logs from pods, sends them in Elastic. In Elasticsearch, we have for all application different indexes. For Kibana is analyze and visualization all this data. As I mentioned, all applications have separate indexes, and some of our applications have sensitive data for us, and they have different life cycles. For high availability, we have distributed data nodes between data centers, and as Kubernetes, we run Elastic into DC, and at this moment we have 6 terabytes data in Elastic. For system monitoring, we have kube state metrics, node exporters, Prometheus, Victoria metrics, alert manager, and Grafana. Kube state metrics generate from nodes these metrics, system logs, node exporter gathering this data. Prometheus pulls this metric, gets this metric from node exporter. Also, Prometheus writes this metric in Victoria metrics. Also, Prometheus push alerts in alert manager, and alert manager is for notifications. Grafana is visualization all this data. Also, in Rancher, you can see these tools: alert manager, Grafana, Prometheus grabs, targets, rules. Also in Rancher, you can see Prometheus rules, and you can see what it does, what it do. We also monitoring our pod resources, CPU and RAM, limited and requested limits. We also monitoring our networking metrics, received and transmitted bytes. Also monitoring ingress requests. There are pictures that you can see we experience some DDoS attack. Okay, now there is Dynatrace. We use Dynatrace for deep diving and troubleshooting. With Dynatrace, we have some big picture visibility. With Dynatrace, we know what components need to look, what components need to change or fix. We are looking response time, our applications, and the request time. Also, with Dynatrace, we are monitoring our dependencies, and it helps us for troubleshoot. With Dynatrace, we know what components need to look at this moment if application have some disasters or problems. Also, in Dynatrace, you can see some statistic of Kubernetes. There are a number of deployments, also memory and CPU. Also, we have a version control. As Becca mentioned, that GitLab is our source control, and Jenkins is our CI/CD for our CI/CD processes. Also, you can see that we are scanning our application, and there are deployment fragments that we use. We change our image tags. Okay. For images and Artifactory, we are using JFrog repository, and we have some repository type in our JFrog. There are some Docker, Helm, Maven, RPM file, Conda, Python, Gradle, and etc. All this file we are scanning X-ray scanner, and I think our presentation is over. Thank you for coming. Thank you for listening. If you have questions, please ask.
Hello. My name is Tigran. I am from Armenia and represent Cloud Venture company. I have two questions, actually. One of, do you already move to microservices totally?
What question is?
First question is, do you already totally move to microservices, or still there is a part of monolith you are using?
In cloud or our data center?
Your product.
We have already migrate our applications, most of the applications in our Kubernetes, and our mobile application is already running in Kubernetes cluster.
Cool. And the second question is, which part of the process of breaking monolith to microservices was most challenging for your team?
I think that was in Dockerization our applications. That's because all applications use different type of source programming language, and in a Docker we must use the same type of source programming languages, and in Docker we run most of the our application. Okay.
Yeah. So let me answer the question that you have. So first of all, actually, we haven't started our process directly. We haven't started to directly migrate into Kubernetes full-blown migration. It was more like we started to use Docker at first for to build our application. So only for the building. So in CI/CD process, we had integrated Docker, and we actually had our environments standardized, to say. So basically, we started using Docker with CI/CD to build our applications. Then we got a little bit comfortable, and then we actually started to deploy our containers just with let's say with Docker Compose, and then we saw that nothing terrible happened. It was okay, and then we actually started to spin up some Kubernetes cluster for our lab, for our testing. We played with it, And then actually we actually said that we want to like take some non-critical application and deploy into Kubernetes. And after this, we have like a lot of challenges, like which Kubernetes we should use, because in on-prem, when we started this process, there wasn't that much of like, there was like OpenShift, there was other solutions like Google Anthos, Rancher, etc. So we had some requirements, we discussed it, and like said that Rancher was the like best fit for our environment because it has like cloud support as well, like you can pretty much do the hybrid. So right now, our most core banking components live in Kubernetes. We haven't like finished our migration, so some applications still are on VMs basically, and it's like monolithic right now. But actually, time frame is like we actually think that in 2023, like Q1, Q2, actually we will have a lot more applications deployed into Kubernetes, and then our like plans are like cloud and like a hybrid.
Thank you. So thank you for the cool description. And a quick question about CI/CD. As far as I understood, you use GitLab CI?
No, actually, we started to use GitLab CI, but there were some limitations of GitLab CI because like older version didn't come with the features that we needed. So we switched to Jenkins, and right now for CI/CD we have Jenkins, and for source control we are using GitLab. So GitLab is on-prem, not the cloud.
And your CD, like continuous deployment on prod, is also fully automated, or are you doing it manually?
So yeah, basically we have like branching strategy, like we have 3-4 environments depending on the project. So environment corresponds, like the branch corresponds to the environment. So if we have like test branch, it goes to testing environment. If we have dev, it goes to dev environment. And this process is like fully autonomous, except some projects are not deployed automatically to the production. Like there is some button and only selected few people are lucky to press the button.
Okay, thank you. Thanks a lot.
Thank you.
Thank you.
Yeah, so our next speaker is Anton. Actually, it's his first time here in Tbilisi, so I want to thank Anton for coming here to Tbilisi, and his talk is about best practices of Terraform.
Hello, can you hear me through this or through this? Oh my God, through everything. So it's my pleasure to be here in this awesome city and awesome country, and I really appreciate the support, which pretty much is easy to feel everywhere when I was walking through the city. So yeah, let's get started. So my name is Anton Babenko. I like to do some things with open source, and I've been doing since 2015 many different projects with Terraform and AWS, and some of these projects you may know or you may use. Well, that's what I do pretty much. I have developed Terraform AWS modules as well as pre-commit Terraform and serverless framework as well, because it's just cool to be able to use Terraform to manage all of your AWS serverless solutions. And then I wanted to share this a little bit more kind of publicly. So in 2018, I wrote terraformbestpractices.com, because at that time there were no best practices, and it was really boring for me to go to different events and start arguing with people, and they said like, oh no, this is not best practice, oh this is not best practice. Then I just decided to make a website where I wrote whatever I thought, and I say that this is best practice. So that's pretty much how it started. Now this Terraform best practices is translated in approximately 12, maybe 13 different languages, and people are translating it because they agree and they want to learn it by doing it. So if you want to translate it to Georgian, you're more than welcome, just let me know. Okay, I don't know actually how much time I have. I don't see any counter, so yeah. Let's hope that if you suddenly get bored, just let me know and I will switch slide. Okay, so Terraform AWS modules is actually more than 50 different open source modules for all popular AWS services. So if you are managing from network stack, from relational database, from load balancer, believe me, you are not the first person in the world who are doing this. So please, please, please look into those, start using them, and you will see that it's actually significantly easier than doing it yourself for the first time and make your own mistakes. It just doesn't make a lot of sense in 2022. It was necessary 2016 when we had very kind of new, now it's well established. And also more than 50 people and organizations are sponsoring my work through GitHub sponsors, so thanks to them. I also like to share whatever I find, as well as, of course, I provide all my humble opinions to everything, so that's part of who am I. And I publish weekly TF every Wednesday. It's newsletter and about everything what I find in Terraform. Every Friday, of course, there is nothing else to do, so I'm live streaming how I do different live coding exercises, or how I fix different issues, or how I solve different tasks, or I just talk to different creators of different tools related to Terraform and, in general, infrastructure as code. So this is my YouTube channel. Okay, let's get started, right? Okay, enough about myself. I really want to make it short, but now let's talk about Terraform. Okay, Terraform in 5 seconds. That's pretty much what I want to kind of to go through, because I believe that as you already raised your hands, that many of you know what is Terraform. So I'm not going to repeat documentation or even try to sell you and say that Terraform is the best tool, because, well, it may be the best, but it may be not the best. We could talk about this afterwards with a great pleasure. Then I want to talk about typical DevOps engineer's life, okay, and what part of their life Terraform takes, and we will specifically look into their perspective. And then I will try to focus on more like really Terraform best practices, which are not really discussable. It's like common ground, okay, because it's very easy to come up with hundreds of best practices, and then we will say like, no, but this is not good, this is bad. So we'll talk about that closer to the half of my talk. So Terraform, well, Terraform is a tool which is by HashiCorp, which is open source, which allows us to write, plan, and kind of manage infrastructure as code. If you don't understand any of these words, that's okay. I will show you a lot of code. So why it actually started? Well, many years ago, big cloud providers came with the idea that we have to have a tool for developers or for everyone to manage and to reproduce the same infrastructure, but on their cloud. So AWS came up with CloudFormation back in 2012. Then Google Cloud came up with something what is called Google Cloud Deployment Manager. It's okay that you have never heard about this product. It's totally fine. You're not the only one. But it exists. Google doesn't use it. So Azure also thought, like, what can possibly go wrong if we allow people to manage infrastructure using JSON? So that's why Azure Resource Manager started. And then, of course, big players from the past generation, I'm afraid to say past century, but no, past generation, like Chef and Puppet, they decided that, okay, it's possible to use our tool to manage infrastructure. And then Terraform decided in 2014 that why there should be so many different tools to manage everything. So let's unite this. And right now there are more than 2,400 of different providers for different type of SaaS solution or infrastructure as a service solution, or just pretty much anything with an API can be managed through Terraform. So think about this. This is quite important, that if you have an API, like REST API, you can use Terraform with it. There are a lot of very cool ways how you can do it. If you want to learn Terraform, and this is probably the main slide for people who are very new to Terraform, and you came here and you kind of already started losing track of what I'm going to talk about, so please go through these links and start them really from the top to the bottom. I highly recommend to read official documentation, because this is where developers put their mind and they explain to you, hey, please read our stuff, follow our guides, read opinionated stuff on Terraform best practices, and then keep following weekly TF newsletter, because that's where new things are popping up every Wednesday. And also, I recommend people to just watch open source repositories, because that's exactly where the magic is happening, and you can see a lot of us discussing it, coming up with different solutions, workarounds, and so on. So, hi, I'm DevOps engineer. That's probably what you're already thinking, because, well, I'm DevOps engineer. Show me what exactly is the value of this presentation, right? Okay, let's put it simple. Let's start with something what we are typically dealing with. We have some infrastructure which we need to implement, because we are working in let's say, Bank of Georgia, and that's the main bank which I have heard so far. You need to describe some infrastructure for that project. So you spend some time visualizing, talking about how your infrastructure will behave, what kind of services will be connected. So you understand this picture in your head. Great. So that's what you can easily understand, talk to many other people. And then you eventually come to an idea that at some point you want to put this as a code, right? You cannot just forever looking at image and say that this is what I do for living. No, you should put it into the code. And then you have lots of different options. So let me just put a few options how you can achieve this. So the option number one is that you are going to look into official documentation for the Terraform. You look information about individual resources, and you implement individual resources one by one. So it's going to be approximately 40 resources with a lot of things hard-coded. So then the next iteration of this is that you are going to try to customize this thing. So you will add variables, you will add outputs to your code, and your code will eventually become 5 times bigger. This is quite normal, but at least things will be a little bit more customizable and more parameterized. Then you understand that, okay, I'm actually dealing with multiple things at the same time. So I can already group things and call, okay, this is module for managing Lambda function, which is similar in 2-3 places. So you're going to put it into Terraform modules. So you can see that your transition is already happening from small things, very static, into something more dynamic. And then you discover that your solution, for example, for Lambda function is not so unique, because Lambda functions have been around for many years, and you discover Terraform AWS modules which implement much more features than your project currently needs. So it's like thinking ahead. So your code will look like invocation of a bunch of different modules for the Lambda function, for DynamoDB tables, for some other API gateway, and for everything else. So that's what your typical life when you're starting with project looks like. Or when you join a new project, you will have to deal with some sort of configuration files like Terraform configs. Okay, then you go back home 1 day after, 2 days after, or even you go on vacation, and then you come back from vacation and you look at this code and you ask yourself, like, what does this code even do, right? You often probably come back from vacation and you ask Git blame, who was this person who wrote this code, and Git blame tell you that this was you, right? And it's like, what did I think when I did this? So this happens quite often, and usually you want to really answer 2 questions, like what does it do, and does it still work as expected? Because I wrote this code like half a year ago, and after that I may change my mind. I mean, I may even forgot what I was doing. So you really want to question, like, does it still make sense? Will it even work if I run Terraform apply and it produced no changes? In many cases, no. Something will diverse, something will drift in all directions, and you will just try to find an excuse to not fix it. So you also want to know, like, after you figure out that, okay, it's good, so how can I actually move forward and add new feature or fix something? So we are coming to a word which I really try to emphasize quite a lot nowadays is understandability. The code which we are writing is not for the machine. It's not for the compiler like it was many years ago. It's not for machine. It's only for the human, for yourself, or for somebody who will join you later. So one of probably top recommendation which I have overall, not just for Terraform, is always try to come up with solutions which are easy to understand. I'm big kind of I'm not big. What is it? Not big? Yeah, small. I'm small supporter of Kubernetes, to put it lightly, because it's usually making life too complicated in places where it's not necessary. So think about this. What would you do to make your solution easier to understand? And we spent at least half of our lifetime, I mean at work, of course, to understand what does this code do, what does the solution mean. And this is not just me saying 50 to 67%. There are even more researchers saying that we spent even more time for that. I just found this one because it is for software project. Okay, well, understandability means that we will be able to look into the code and we understand from the higher level what exactly is happening, like what kind of services are there, what kind of inputs, outputs, and we normally can use existing tools which can help us to do that. Like we can generate documentation, we can fix very easy linting errors, or we can highlight them. We can do some security analysis of our code. This is all implemented inside of pre-commit Terraform. Or we can actually do a little bit of kind of help if we make diagrams as code, so that we write code in, let's say, in Go or in Python, and it will produce a small image of our code, of our infrastructure as an image, which we can then embed into Confluence or any other place. It's very easy to implement using diagrams, for example. Or we can even visualize everything what we have inside of diagrams using different other solutions or services. So yeah, you don't see pre-commit Git hooks for Terraform. This is pretty much the whole configuration which you need to put in your configuration file, and then every time when you run git commit, it will format your code, it will validate that this code actually is executable, doesn't contain syntax error. It will generate documentation for inputs and modules and resources and a little bit more. And it will also lint the code to tell you that something is wrong and it's better if you fix it right now. It's really important to think that a lot of these things has to happen before CI tells it to you, but on your machine. You need to think about this as shift left, and you do a lot of things in advance before your colleagues spend their time and tell that, hey, you misaligned this thing, or this code has syntax error. It just doesn't make a lot of sense. Fix it and then try to talk to your colleagues about much more relevant stuff, much more complicated stuff than aligning YAML, right? It's a lot of fun. So let's put it another way. Understandability also means code structure. If you have a decent code structure and you understand what does this code do just by looking at code structure, I mean at some folders, some file names, it will be much easier for you to understand, and you just will spend less time struggling with it. So when you're using Terraform modules, the first thing when you start working, obviously you start with small resources, and organically, as you are progressing by introducing Terraform in other places, amount of code and resources and environments which you're going to manage with Terraform will grow. So currently, I know pretty much two groups of people who are not aware even about existing solutions for them, which can boost their productivity like a lot. And they are struggling by following official documentation, by coming up with, by learning the underlying services instead of just using and then go deeper as you need it. If you are from software development background, think about Terraform modules as a library. When you're working with your favorite programming language, it's not every day when you're writing packaging or implementation of archive algorithm, right? You're probably going to use some library, some function which has been around for many years, and you will just call it. The same with Terraform modules. And yeah, search in Terraform registry. There are quite a lot of good solutions. So let's talk a little bit about how to structure Terraform code. I still have a little bit of time, so that's good. And yeah, first thing first is how to structure Terraform code. You have pretty much a way which I call all-in-one, where you have Terraform configuration files. Usually it's one big file or multiple big files where you are invoking pretty much everything. You are invoking creation of VPC, of load balancer, of security groups, of many, many different things. So then when you run Terraform apply on this code, it will just take a lot of time, and a lot of things will have to be verified because they are too much interconnected. But on the opposite side, there is a one-in-one way of grouping it, where you are looking into your infrastructure and you are describing it in a way that only certain units are managed at the same time. So for example, if you are managing VPC, it's just VPC. It's not everything else what it relates or depends on. So in general, the scope for this change will be significantly smaller, and it will be just easier and faster to work with. There are a few downsides, like you will have to implement some sort of orchestrator to go and to traverse through the dependencies. So which means that if there are changes inside of network configuration, you will also need to go and apply changes where this is in use. So it's a little bit challenging sometimes, but it's doable. So let me ask you guys a question. If you imagine your typical kind of project at work, how do you normally group your configurations? Is it like all-in-one, or is it one-in-one? So all-in-one is one big file or many big files where Terraform apply will take 10 minutes, 2 hours. I mean, 2 hours, I have heard about these cases. Even I think 4 hours somebody told from the audience, and I was like, oh my God. So 4 hours, it's like you come to work, you do something very quickly, run Terraform apply, and that's day over, right? Let's dream work, you know. Sorry? Yeah, exactly. Yeah, so then you continue next day and you fix your typo and like, oh my God. But what is the even bigger disappointment when you type yes to confirm it with a mistake, right? Yeah, there are a lot of things which you can do. So think about this and raise your hand if you are using, let's say, all-in-one. Yeah, no, don't be afraid, it's okay, it's okay. It's okay, one person raised, this guy. Okay, What about one-on-one? Yeah, right. You see, so a lot of people think that they're doing it one-on-one because it's good. Well, in reality, it's not even comparable, because when you are starting on something what you have no clue about, you will put everything in one file, and it will grow, grow, grow in all directions, and then you will see the pattern that something is repeatable, or something is possible to externalize, or something is not even needed because you found a module for that. So you will eventually start with all-in-one, and then you will prototype, and you will go probably to the direction one-in-one at some point. Only if your things are very tightly connected, then it makes sense to stick in all-in-one and work with this as a whole unit. But one-in-one allows a lot of very smart patterns. For example, it's allowing your developers to cooperate in a way that one group of people is responsible for a certain stack, for example, network stack or security stack, and another type of people are responsible for specific application-related infrastructure, for example. But it also allows us to facilitate this by using different tools like TerraGrant or TerraSpace or TerraMate. If you have not heard about TerraSpace or TerraMate, that's completely okay. They're very niche, but TerraGrant, you should look and you should consider it if you are not using it, but you are using just typical Terraform, I mean standard Terraform without any orchestrator or code generator tool like this, which I specified. Well, infrastructure testing, because you probably also want to understand, does it really work? Like when I have to review some Terraform code, I look at it and I always mentally executing this code in my head. I hate doing this, honestly. When people ask me to review pull requests, I can do it. I mean, I do it every day on my phone, no problem. But every time I'm thinking that that's not exactly the way I wanted to spend my time, by executing this code in my head, and then loading Terraform state on another part of the brain, and then compiling it in my head. It's just wasting of time. There should be something better. But the reality is that the best way of testing in Terraform is actually to push it to the master. Wait for half an hour to people to complain. And they will just tell you that, hey, you did something bad. You don't have to think about this so much in your head. Okay? Okay, if you took it too seriously, that was a joke. But no, in reality, you can do quite a lot in your head, but you will still be surprised by the amount of mistakes you can easily not see when you just look at the code. So the field of infrastructure testing is pretty interesting for many people. But the way we are dealing with it right now is we are coming up with too complicated solutions in most cases. People are adding TerraTest and they demand to write tests in Go, for example, or using some other artificial and very, very complicated framework like testing frameworks in addition to Terraform. What I find really helping me, and that's what I've been doing for many years, is really focus on, if you know what is 80-20 rule, where you spend when you spend, well, anyway, you spend something, you have to do something what produce best output. So doing static analysis on your laptop when you are typing code usually will catch a lot of things which are really critical and really important. So running tflint or Terraform validate in automation or on your laptop in pre-commit phase, this is very, I mean, I don't know how many percent it will take away, but I would say that 50% of issues are easily eliminated on very beginning. And also don't be afraid to run Terraform examples. In all places where we are saying that this piece of code is now available and everybody can use it, we always have to confirm it somehow. And the way how we establish this inside of Terraform AWS modules is that we have examples. if there is a feature, then in very high probability there is an example for this feature, and you should be able to run Terraform apply in examples, no matter what kind of combinations of, but like no matter where you are from, what kind of environments you have. They're really very small and very specific to the feature. So don't be afraid to run Terraform apply on examples, and if it works, then there is very big probability that the code works. Whether it works as expected, that's another thing. For that one, you will probably be better to do something like on the next stage, like deploy application. And if deployment failed, then infrastructure was not ready. So how to get feedback quicker? This is also something what you probably think about when you're writing code, and you often may feel that you write code on your local machine, and you have Jenkins, and you have manager, and you have code review, and you have somebody else, and then it will be executed on a test environment, and then on staging environment. Right, you see how many steps are involved. And when I work with companies who say like, oh, we are all about security, like we are bank, we cannot allow this. They introduce 7 steps of this before code will be actually executed on test environment. This is absolutely wrong. So make sure that you are having everything what you need to run this specific code which you're writing on your test environment. So have yourself a test environment which is somehow similar to what you have in staging or production. Of course, you don't have to have the whole secret data on your laptop, but you can still emulate a lot of things. So that when you're writing a piece of code or Terraform module or Terraform stack or anything bigger than that, you should be able to reproduce it or run it at least on your environment really effortlessly. So running Terraform apply on your local machine, that's dream because it's quick. Of course, it's very hard to sell for different SaaS solutions who say that, no, you don't have to run it on your local, always run it on us. And by the way, we're charging a lot. So no, I like that when you have possibility to use the same policies, the same guardrails, what you have on your real environment, but applied them on your local environment. For example, using local stack, it's free. You can just run your infrastructure, get it quick in 2 minutes, which will at least guarantee that your code works in a way that you expected. You don't have to wait for 7 generations of all managers and tools in front of you to see that, oh, sorry, build failed. That's not right. You should not wait so much. Of course, if you simplify the code and you try to remember that there are quite different expectations from different groups of people. For example, people who are writing modules and people who are using modules. They have very different expectations and very different knowledge set. So for example, if I'm writing as a Terraform module developer, I need to know a lot about internals of Terraform, of cloud provider, of service and limitations and many more than people who want to have just implement the infrastructure. That's it. They don't care about what is even HCL1, HCL2. I don't care, I just want to make this service, so I will provide 2, 3 values using some data source to get more dynamic information, and that's it. That's a dream, like you have very 2 different groups of people. And when you start thinking about this in your organization, you will definitely see a lot of high quality because people will decide to focus on one, and people will say like, oh, I actually don't care about Terraform at all. So, but I still want to create my infrastructure. Great, you're from now on official Terraform module user. That's it. But if you want to go deeper, then you need to know a little bit more, and you will have to contribute, open pull requests, do some reviews, and so on. So think about different expectations is pretty much the key to have feedback quicker and high quality feedback quicker. Oh, I already have summary. That's pretty cool. I thought I have 20 more slides, but it's okay. Well, think about what does this code do as understandability. Always try to focus on proper code structure as a driving mechanism for other people to understand what's going on. Don't try to win a competition to write everything in one line. Okay, you can do quite a lot of things, like you can even use JSON if you want and write it in all one line, but it sucks, really. It's not the way it should be. And when you're thinking about does it work as expected, try to focus 80% or 90% of what is really, really simple. TF-lint, TF-seg, pre-commit hooks, all of this will increase your quality of the code significantly, just without any efforts. And you will also learn why certain linting rules are actually there. They're not there just for fun. They are to help you to form your code in a way that you will understand. Like when I'm looking at my code, I immediately understand where to look without going through all files one by one, because code structure and small things are very simple, very easy to comprehend. And again, we are writing this all infrastructure as code is absolutely not for machine. Don't try to make things quicker for machine or make smaller files because you think that machine is, I don't know, machine we are paying for disk storage. No, write for humans first of all. If you think that something is not obvious even in your configuration, don't be afraid to put comments. Put links into other GitHub issues on Terraform provider around place where you added certain lifecycle, ignore changes because people will ask you. And yeah, do not afraid to run Terraform locally. That's, again, one more advice which I want to give, because I can see that a lot of organizations are trying to apply security first by removing developers completely. They say like, oh, we are too secure, that's why we cannot allow you to run Terraform locally, but we have process, so please commit your code, open pull request, somebody will review, some analysis will run, some, and then we will deploy it eventually to our test environment. That's like, oh my God. No, I have my own environment on my local, which is fine. Oh yeah, I have place for questions. I really want to hear your questions. I'm here pretty much the whole day, so anyway, anytime we can talk about anything else, not just Terraform, Terraform for CDK, for example.
Hello, my question is about best practices for Terraform, and what do you think, your advice is for avoiding Terraform drift? Like what to do to avoid? And the second question, if like we work in big teams and people do some manual changes, etc., if we have configuration drift, couple of tips how to fix it quickly and without pain. Thank you.
Yeah, thank you very much for your question, Tigran. So the question is pretty much about infrastructure configuration drift, which is, well, so two of your questions are connected to the same problem, is that, first of all, why it existed. Probably the team is so big and team doesn't have enough kind of understanding how to do effective things in first place. That's why they fall back to go to click ops operation and click in console, and day is over and the rest is not my problem. The way how to prevent this is, like, there are two cool ways which I discovered recently. You can shame these people publicly in Slack. You can shame them by using, again, if human shame other human, it's bad. But if machine blame human, it's really good. The way how you can do this is that in AWS you can use CloudTrail API, and there is a user agent string, which means that if user agent does not contain Terraform, then this means that this API call was performed by this IAM user. And then you can send Slack messages in specific place by saying that, hey, this guy, this username just did something. And in general, it's one thing how you can detect this drift. Like not drift, but you can detect that something is not right, so we need to take a look on that one. But another thing how you can actually discover this drift yourself is by running Terraform plan in any CI fashion you want. Every 15 minutes, for example, can be very effective. But of course, it can be not necessary, for example, during night, but every hour, for example, it's almost free. Like you don't pay for get operations, for example, or not get, but describe operations. So this way will be very effective for you to discover this drift. If you want to run Terraform plan, you will see exactly how it is different. Or you can use another tool, which is driftctl well, now they're part of Sneak. This is also open source tool, which allows you to see in a little bit more detailed way of what exactly drift is. So it will compare not your infrastructure code, but it will compare your Terraform state and your actual resources. So this is a very powerful way, and it's very quick. Really, it's I don't know, 2 minutes to scan a lot of resources, and you have very nice output, which you can of course put every. Usually, I saw people put it right before their stand-up, like 9 o'clock in the morning. They see big drift detection, and then they decide whether they have to do something or they can forget about it. Shame publicly works really good. Really. I like that. You agree? Yeah. Any other questions?
And the second part of the question, like couple of tips how to fix if we have like, do you have any special tips of just go to look into the state file, compare, edit, and fix?
Well, there was a discussion for many years actually to bring a command inside of Terraform, which is a Terraform add, to help you with such drift detection, so that when it identifies what exactly has changed, there are ways to actually update your code and pretty much open a pull request to your code base by saying that, hey, we discovered that somebody changed from 5 to 10, and do you want to merge this pull request? So it is possible, but it's from what I remember, it works a little bit better for Azure resources. But this is like technical part. From human point of view, usually teams are just much more comfortable with fixing it in ClickOps way. That's, you have to fix that first. Once you fix it, it will be quite easy to do technical reviews 9 o'clock every day and fix small things technically.
Okay, thanks a lot.
You're welcome. I think I still have time, so more questions. Yeah.
Thank you. Hello, my name is Kevin. I'm from Madison, Wisconsin. Very happy to be a guest in this great country and great city, so Madloba. My question, and really maybe what I'd like to maybe hear your thoughts on is developer self-service. So I'm a cloud engineering manager, and our goal is to enable different squads, pods, to build their own infrastructure. So do you see developers continuing to adopt Terraform, or maybe what do you see as the kind of future forward?
Yeah, that's a very good question about how to pretty much let developers to have a good time by using Terraform. As I started the presentation by saying that I don't want developers to learn Terraform from the bottom up in order to build what they want. They need to have a little bit higher abstractions, like Terraform modules, or even compositions, or collection of modules. And the way how I see this have been implemented for many years was that people have pretty well-defined patterns within their organization. For example, how do we deploy a load balancer? Well, in our organization, we use this Terraform module with these parameters. Great. So as a developer, I don't need to have anything else than a link to my Terraform patterns page and scroll through it and see, okay, this is what is approved way of deploying a load balancer. Good. So I pick this module with these parameters. Then they scroll and pick up something else, what they need. This is the way how it was working before, and it's still working pretty successfully with big organization too. The way I see this and the way I want this to be kind of going is, again, shift left even more. Developers, to my opinion, should not be required to leave the IDE even. If they want to work with Terraform or describe infrastructure, they should not go to 20 different places, like different URLs, different console, different terminals. They want to edit text files, and the IDE should suggest them what is the right way for us to do. So as you type module block, the pre-selected, pre-approved pieces of infrastructure within our organization is suggested to you right in front of you. So that's the way how I think it has to go. It's very long way to go, to be honest, and I have one project where I worked on it before the war started, and we still continue it, and it will be in this direction. It's called modules.tf, because, well, everything in Terraform is module, essentially. And my vision is that we are not going to demand or to need anything else than pretty decent text editor. I don't know why there should be, why things should look so complicated. I mean, of course, we will get paid more if it looks complicated. That's why we have Kubernetes. But in general, things should be really as simple as possible. And that's one thing which I want many people, many developers to understand, that Terraform is hard if you make it hard for yourself. But if you want to describe infrastructure, go one level up. Don't look into internals of it. Go up. And TerraGrant, for example, as a tool, has a lot of concepts which you can utilize to not know internals right away. You can always go deep if you need, but in many cases you can just be up as a developer, platform developer, or Terraform platform developer. I highly recommend to use things like TerraGrant. Yeah.
Thank you.
More questions? Yeah. Tigran, you can just say, we hear you well.
Another question, Anton, about tacos. So I've never heard about tacos, so the first time here I heard about that. So it's interesting to me, is it like, can we compare the functionality of tacos with kind of functionality of Terraform Cloud in terms of runs, in terms of policies and all this automation? And like, if you did some differentiation, what is your cons and pros? Thank you.
Yeah. Well, the question about tacos, tacos is short for Terraform Automation and Collaboration Software, Service, or Solution, tacos. So Terraform Cloud or Terraform Enterprise is one of service which people can use. Others include N0 or Spacelift or Scalar or Atlantis. They all supposed to help you with executing whatever you have written. So first you write stuff on your local machine somehow, and then you commit it, and then some system, it can be even Jenkins, but Jenkins is much more universal, while tacos are specific for Terraform execution workflow. They have some integrations for the state and so on. So yeah, which one works is pretty hard for me to to tell. I was advising some of them for some time. I cannot say that like anything good or bad about any of them, to be honest, because I don't use pretty much none of them right now. I mean, I use all of them at like different fractions everywhere, but there is not single one which I can say like, oh, this is the future, and like I want to forget about everything else. They have their unique sales points everywhere. On Weekly TF, I published many different blog posts specifically reviewing like all of them, not by saying like this is the best one because of these points. These points, like you can go to their website and read, and they will all say that they're the best. But in reality, I did quite a lot of reviews of all of them on my YouTube channel, as well with the CTOs or with some lead developers of these tools, where I actually tried to achieve certain things and I failed. And that's how it is. So it's not always working as expected. So you need to be very careful, as everything, marketing BS is quite heavy everywhere.
Thanks a lot.
Yeah. Thank you. Yeah.
My name is Mushek. I am from Armenia, Synergy International Systems. First of all, I want to say thank you for awesome presentation. That was super interesting. And regarding to my question, do not afraid to run Terraform locally. I'm always afraid to run Terraform locally. After Terraform plan, I'm always afraid to run Terraform apply. And my question was, is there any tools like TerraGround or some other tool which after running will say like and run try run and try to bring up resources and without changing TF state file to make us sure that everything will be okay and we will not fail at the end?
Yeah, that's a very good question and very kind of very big question at the same time, I have to say. The simplest thing, again, is part of Terraform, Terraform CLI itself, where you can run Terraform plan into a file. So you run Terraform plan -out and then specify file name. So this will produce a binary file, which is actually zip archive. You can look into it and see something fun there. Then next time when you run Terraform apply, you just provide as an argument this produced plan output into it, which means that nothing what you have not seen will be applied. Only what you saw in the plan will be possible to apply on the next stage. So this is like the default guarantee that what you saw. It has some limitations when you are dealing with files or when you're pointing to some external file name location. You may have surprises, but it's very seldom when you do this. So this is when it comes to internal implementation. But in general, when you have some sort of concerns that, like you want to have dry runs, or you are not sure that things are going to work as expected, this is an indicator that you are missing some sort of very safe environment, like your test environment in disconnected AWS account, for example, where you can create the same stack what you are going to apply on your next, like more critical environments like staging and production, but you want to experiment with it. You want to try different versions of tools, different versions of modules, different parameters. You want to see that upgrade will actually happen without downtime, for example, or not all resources will be dropped and then recreated just with different IDs. So you need to have some sort of very safe playground. When you have this playground and you combine it with Terraform plan into file, you will have significant better guarantee that things will go well and you can just proceed with that. If you are talking specific features about different providers, like on AWS, you can have quite a lot by using limited IAM policies, for example. So if you have IAM policy which forbids you to do something what you really never ever want to do. For example, you don't want to disassociate elastic IP address because once you remove it, it will be gone completely. And that's not the best feeling because when you lose it, you need to update a lot of partners, a lot of dependence on this, and it's just not the right feeling overall. So try to put your IAM policies a little bit more restrictive so that you don't accidentally buy something terribly expensive or don't do anything what is tagged, let's say, environment equal prod is denied when you're using this IAM role. This will give you a little bit more guarantee that things will not go bad. Yeah, you're welcome.
Hi, my name is Vagarsh from Armenia. So my question is regarding code analysis, but for Terraform and vulnerability checking.
And what? Yeah. Last part, what you said.
Vulnerability checking and code analysis for Terraform. What do you recommend, or what do you use?
Well, I use Chekhov and TFSec. Again, I use most of these tools on my laptop before I commit code, and also the same execution is happening on GitHub Actions or on some other later stage with exactly the same configurations to prevent from situations where developers run git commit -n to skip execution of hooks locally. Well, there are, I don't know, maybe 20 different tools right now in all of this field. All of them are competing. All of them are saying that we support 500 checks, while another company says, oh, we support 550 checks. Do you care about this so much? Probably not. What is really important is that the real way how they measured. So there are two types of security analysis in infrastructure as code. Well, I guess in general, but in infrastructure as code it's quite visible. There is static code analysis, which analyzes just your code as it is written. And then there is dynamic code analysis when it takes into account your real environment as it will be executed later on. So for example, it can go to your AWS provider and see that, oh, by the way, right now this port is open, but you are trying to close it, for example. So it will go a little bit further than your static analysis, and it will perform more real checks. It's slower, but it will have a little bit higher guarantee that things are actually taken into account. Analyzing Terraform configuration files by these tools is not terrible as it was about 2 years ago, where they said that, oh, we catch everything. But then you use variable inside of count, and then it just doesn't work because it's static code analysis. It's not executing Terraform, or it doesn't have any notion of understanding of what is HCL. So just analyze, like CMGrep is another tool which is popular inside of other languages to do very sophisticated code analysis, but it's also static code analysis. So I would say that currently there are no very clear winner who says that, or I mean, who I can say that, oh yeah, they're doing absolutely a superb job by giving you 100% guarantee. All of them are more or less on the same field. Chekhov and TFSec are top in this field. Yeah, well, there are also kicks. Some of them already went bankrupt because they couldn't understand what does open source mean. I mean, they made product which was very cool, very ambitious, but they were not able to sell anything. So they just decided, like, okay, screw this Terraform thing, and yeah. And yeah, one last thing I want to add is the Open Policy Agent, OPA, and the whole field around OPA is where the policy configuration is going to happen in the near 2-3 years, like very actively. OPA is a tool which allows us to write policy in Rego, which is another configuration language, where we describe like policy, I would say. But the thing with OPA is it has very big ecosystem, and it works with not just Kubernetes resources, but it works also with HCL through a project called ConfTest. ConfTest is also a very popular tool which allows to write policy and apply this policy in CI very effectively. So, yeah, you're welcome. Questions? It's so good that you have so many questions, mostly from Armenia, though. I see. Okay. So Georgian doesn't have any questions, so that's good.
Yeah, thank you.
Okay, yeah, thank you.
Thank you, Anton, again. And now the fun part of the conference, the lunch break and the food. So we will gather at 2 p.m. again here, and we will have Nana Janashia, and her speech will be about all as a code. So like we have like a 1 hour break, and we are waiting you guys here at 2 p.m. Thank you.
Okay, so our next speaker will conduct her speech online, remotely. So here is Nana Janashia. Welcome her.
Awesome, thank you. All right, so let's get into it. So we're gonna, as I said, we're gonna talk about infrastructure as code and so on as code. So basically, everything is code, and I'm gonna explain from the standpoint of why did this trend even become so popular? Why is it so valuable? Or answer the question, what is it so valuable and hype-worthy? And do we need to really code everything, right? And in that context, I'm gonna talk about the pipeline as code, which is something that was already there before the whole concept kind of became the buzzword. We're going to talk about the concept of infrastructure as code, which is the one actually that popularized the idea and the concept. And we're going to go over configuration as code and cover some examples of network as code, security as code, policy as code. And there should be actually 3 dots there because there are more additional stuff actually being added as things get automated even more. So let's start with the example of the first X as code. And I'm going to start by telling you about one of my projects where I was actually a software engineer. And we were developing a project for our customer company, which was an IoT system where a couple of applications were kind of involved in this whole system, right? So every time we had a sprint end, which was in 2-week cycles, and it was time to demo the new features that we added to the customer to show them how much progress we were making, we had to do the following. And this was our release process actually at that time. So one of the senior engineers would go and check out the main branch or master branch. We would then increment the version in the settings or build a Gradle file manually. Check that in Git repository, which will then trigger the CI pipeline in Jenkins, which would build and build a Docker image from the application and push it to our Nexus registry. And we would do this actually for each application that was involved in this whole IoT system, right? So we had like Android app, web applications, so kind of 3-4 components, and the process was the same. And then once we had all these images in our Nexus repository, then again, one of the engineers would continue the process, and we would pull those images to the server and start them with Docker Compose, whatever, and kind of start the application there. And that would be a server we used for demoing the features to the customer when they arrive, right? So now if you think about this whole process, notice the spots of manual intervention within that process, right? So anytime we had manual work, we had a lot of drawbacks there related to that process. So first of all, it was slow, and we had a bottleneck of an engineer basically having to take time from developing features to kind of having this super focused 1 or 2 hours of making those commits and then making sure the deployment, the pipeline went through, and then pulling those images, making sure that when they started, everything was working fine and was ready for the demo. So basically, this was a slow and painful process, and it needed a lot of concentration, and it was pretty stressful because very often we had cases where the customer was on the way, like they would arrive literally in 2 hours, and we would be sitting there waiting for the CI pipeline to pass so that we could take the image and deploy it to the server and then kind of make sure that everything was working. So we have, additionally, we had this human error issue and so on. So to solve these kind of issues, we have manual interventions. We have end-to-end automations, right, for the pipeline. So ideally, your pipeline should do everything automatically once the code is committed. So in this case, you would the pipeline itself would automatically bump the version, build and automatically deploy the application to the demo environment. So your only manual work is code commit. And the automation, which is the word that I mentioned, sorry, what I mentioned a couple of times, is actually the underlying principle, so the most basic and important underlying concept of the X as code concept. So that's basically where everything starts. As soon as you need automation, you are getting into that X as code mode or X as code area, basically. And this example that I just mentioned now, that I explained, is one of the X as code examples, which is pipeline as code. However, if you think about this, developers actually had these pipelines even before the whole idea became popular, right? Before we start talking about infrastructure as code and automations and X as code and whatever. So maybe it was not as streamlined and end-to-end automated, but developers had semi-automated pipelines, at least for the CI build, right? So we didn't call it a pipeline as code. We just said we have a pipeline that releases the application. So the idea or the concept that actually made this popular was when the infrastructure as code kind of came into the picture. So basically, developers had version control. So we were working with Git already, and we had our Jenkins build automation. So naturally, we had some kind of X as code, or in this case, pipeline as code. But when you think about the automation part, that was the operations part or systems administration part, that was really not automated or lacking this kind of collaboration with version control. We basically collaborate on the code, and not people or operations engineers having their own random scripts that they kind of keep locally and then execute to provision infrastructure, to configure it, and so on. So that's where the actual demand and need for automation started to appear, right? To automate processes within the operations side of the software development lifecycle. And that was actually what popularized the term even. So, and that's where the infrastructure as code basically comes into play. So the biggest chunk of the presentation is actually going to be on infrastructure as code, because I think it's also the most encompassing and the most important one in the whole list of X as code examples. So let's actually think about how the operations engineers worked before infrastructure as code became popularized, and what are actually the advantages, or why we kind of push the operations engineers or even systems administrators for doing network configuration, maybe database configuration, whatever, in that direction to say, hey, you need to automate stuff, you need to collaborate, you need to use version control, and write everything that you're doing in code. So let's talk about that. That's next. So first of all, if you are operations engineer, or you have been, you probably know that this is how the workflow used to be. So whenever it was time for new infrastructure to be provisioned, for example, developers needed, a developer team needs a Kubernetes cluster with 3 master nodes and 6 worker nodes, right? So the systems administrators, people who are managing servers maybe, they would have to actually provision those. If you have some bigger company with bureaucratic processes, then you have to submit an request that you want these servers with these kind of resources and so on. And then you would kind of configure the firewall rules, open the ports that are needed to access the different cluster components, install the stuff that's needed, the binaries, the tools, etc., to kind of prepare it for the developers. So the way this would work is, as I said, either having a UI where you can configure this stuff. For example, if you're working with AWS cloud and you are having the whole infrastructure basically on AWS, either you would go to AWS UI console and configure all these services there, or you would use AWS command line interface and kind of script the whole thing. But essentially, you still have this manual process where someone has to go and manually define all these things and then execute them and then check that everything actually got provisioned and then SSH into the servers. And then you have a bunch of random scripts that kind of do stuff. And if someone else basically came on the team and said, I want to basically replicate exactly the same cluster with the same configuration, how do I do that? You would basically have to hand over those scripts, and maybe you wrote some documentation in the Confluence page that describes the step-by-step process of how you did it. Plus, if things change, like Kubernetes version change, for example, maybe some of the steps doesn't work anymore. So you have this kind of issue of transparency. You couldn't replicate the current infrastructure configuration exactly as is very easily, because you would have to remember yourself what you actually did. Usually people would use Confluence to document this stuff, but mostly either the Confluence page gets outdated, so it doesn't actually work anymore because things changed and the versions got upgraded, or people don't maintain that anymore, right? So it's really difficult for a new operations engineer to get on board and kind of collaborate on the existing infrastructure, and you don't know what the status is, right? You don't know what state of the infrastructure you have, because you don't know in which order you executed the script, you don't know if the Confluence is up to date, and so on. So you have this bunch of issues of transparency, collaboration on infrastructure, and so on. And these are actually exactly the things that infrastructure as code basically came in to solve, right? So there are a couple of ingredients of this infrastructure or access code that always basically go into the recipe of having this access code. One of them is automation that I just mentioned, which means you don't have a human just sitting at their computer and executing some stuff. The tool is executing things, executing commands and workflows. And the second ingredient of that is version control. So this is actually the part which was kind of the biggest impediment in the operations side of the things, because developers work with version control from the beginning, because that's how you collaborate on the code. But sharing code and keeping the code for infrastructure configuration, or even those scripts in a version control system, was actually not the usual thing to do. So that was kind of the new thing, the novelty in this whole concept, more than the automation. So version control is something that solves a couple of problems that I mentioned, which is collaboration. So for example, imagine you have two people that are working on infrastructure, and they have provisioned infrastructure, they have configured, they know what the state is. Now, let's say a new team member comes in, maybe they're a junior engineer, whatever. So just by looking at the code in version control, they can actually independently start learning and understanding, okay, how are we provisioning our infrastructure, what is the configuration, what security configuration do we have in place, and so on, without having to go to these engineers and have like sessions where, please explain to me like, what is the state of this, how did we configure that, right? So having the version control actually makes your knowledge sharing way easier and onboarding way easier, because you have the code in version control as the documentation of your infrastructure. Right, so by just going to code and reading the code, you know, if you learn and understand that code, whatever language it's written in, Terraform, Pulumi, or whatever, you understand exactly what state your infrastructure is in, right? So you have the knowledge sharing, you have collaboration. So for example, again, if you have a junior engineer and two seniors working, the junior engineer can independently change parts of the infrastructure configuration, basically commit the code, and you can leverage this whole, pull request, the Git features of collaboration with, writing comments back and forth, giving feedback, and kind of perfectioning the code to the level that it's mergeable into the main branch, and then you can apply that to the actual infrastructure as the change. So this version control component basically covers that part. Collaboration, transparency, documentation, and automation covers the part of removing the bottlenecks, slow processes, manual, error-prone services. So the combination of these actually gives you exactly the benefits of anything as code, but in this case, infrastructure as code, which was actually super important introduction into the whole thing. One of the things actually that led to infrastructure as code and why it kind of became the thing is when DevOps kind of became the popular thing, a lot of companies, because of lack of knowledge or whatever, they kind of pushed the DevOps onto the developers and said, you are developers, now you have to also manage how your code is run, right? So kind of you build it, you run it now. And because developers already worked with code versioning and so on, they kind of took over the part of, okay, now we have to code the infrastructure as well. So this trend of assigning the DevOps tasks to the software developers was actually one of the reasons or one of the contributors of infrastructure as code even emerging. Or even in cases where in DevOps teams you just have no dedicated DevOps engineer, but you have developers and operations now just coming together and working together, that made it also easier to implement infrastructure as code for operations, because they could leverage the knowledge that developers had on how do we use Git, how do we code basically in this kind of workflow. Which actually leads to the in practice example of a lot of operations engineers being against or kind of being persistent against the infrastructure as code. So this actually works very way easier in DevOps teams where you have Dev and Ops collaborating, because you kind of have this combination or collaboration between software engineers and operations engineers, so they can actually leverage their parts of the skills to start implementing infrastructure as code. And now we also have to talk about the tooling, because these are the benefits and advantages that you get from infrastructure as code in terms of the workflow. So that makes your work process basically faster and so on. But you also have benefits on the technological level, right? So one of the most popular tools for infrastructure as code is Terraform. So if you know IAC, you probably also know Terraform. There are obviously other ones like Pulumi is actually one of the really good ones, but Terraform kind of emerged as a market leader for now. And with Terraform, you actually get the benefits of the tool itself, because it has the features that makes your work even more easier, which is logical, but it also adds to the benefit of just the workflow advantages. Basically, when you script infrastructure as code, and this is actually one of the advantages that Terraform gives you, when you script infrastructure as code let's say with a simple bash script or PowerShell script or whatever, you need to check the state yourself, right? So if the server isn't already running, you have to create one. Or when you create the server, then you have to fetch the IP address and then connect to it and configure something on it. And then you have to check again the state, is this tool already installed on the server? If not, I can install it. So your script is very low level and very detailed because you have to really tell every single detail of what you need to do. Because otherwise, you either, so when you execute the script many times, you either get error because it says this already exists on the server, so you can do that again, or you get some weird results because your configuration is not idempotent, so you kind of change stuff that you were not supposed to change. So this could be a big issue, and this could also be very error-prone. And this is where the tool like Terraform, again, helps you. And Pulumi actually has the same thing, which is state management. So when you write the code, it's more declarative. So it doesn't make you write every single step like in detail, like do this and then do that and then fetch IP address. Basically, it lets you define, I want this many servers with this parameters or resources, CPU, RAM, whatever. I want this configuration, and you also have a way to reference different resources like the server IP address or the VPC or the subnet using variables. So you don't have to fetch the information from the AWS, for example, or whatever infrastructure platform you're using. You actually have that in the Terraform code as variables, so you can reference that very easily. So the tool itself actually makes your life way easier. And as I said, when you are in the infrastructure as code area, you have to, so with Terraform you have the automation, and you have to obviously use the version control. So you write Terraform code, and you basically commit that to Git repository, and now you can have all the engineers that are involved in infrastructure management, infrastructure provisioning, working on Git on this Terraform code. And again, some of the advantages here is that code is in the central repository. So what happens now if your whole infrastructure basically just blows up, right? So I don't know, you get hacked or something happens to the data center, so all your infrastructure that you built is gone. Well, you lost the infrastructure, but you still have the complete code representing your infrastructure, right? Which means ideally, you should be able to basically take your Terraform code, pass an AWS credential, account credentials to that, or to other platform, and it will spin up exactly same infrastructure with the same state that you had before. So this automation part basically makes the whole process easier and makes it way faster than you would do if you had to go to Confluence page and read through the documentation and execute some scripts and so on, right? So you have to kind of all hand it over to the Terraform. And there is one thing that I actually want to mention here in terms of this easy replication of infrastructure, or if it just completely dies and blows up, having a possibility to completely recreate it from scratch with the same exact state, which is another trend that we are actually seeing in the whole cloud and deployment area, which is stateless infrastructure, right? So basically the concept of pets versus cattle. And basically the trend is that you should treat your resources, like servers mostly, not as pets, like nurturing and loving each server individually. And this is actually what was actually happening traditionally before the IAC, when operations would configure servers with special things and dedicate a server to a specific task, or save some data or script files on that server, or they would have data on the hard drive or the virtual hard drive of that specific server, and they would know the server by its name or IP address. So it was like a very precious server, so losing that, so if something happened to the server, they would actually try to recover it at any cost. because it was difficult to recreate that server exactly in the same state. And the trend is actually to move away from that kind of having specific servers that you cannot easily replace towards stateless servers, which are completely isolated from the data and basically is replicable and replaceable very easily. And you have to have that in place in order to leverage the automation with Terraform or any other tool in infrastructure automation area. You have to have the servers stateless. And I believe this trend was kind of forced by the development of Docker and Kubernetes, because Docker and Kubernetes conceptually are actually completely stateless, right? Docker and Kubernetes say, we don't care about your data or how and where you manage that. This is a workload which is stateless. If the container dies, we just create a new one. If a pod dies, we create a new one, which is exact replica of the previous one. So you shouldn't be relying on that container or pod running forever. It should be replaceable very easily. And that trend led to thinking about how to make the whole infrastructure stateless, which becomes actually easier when you're using containers and Kubernetes. Because with Kubernetes, for example, you have the Kubernetes cluster and you have the data completely separated. And ideally, and I've seen actually some engineers or some projects do this as well, they would actually store the data on the worker nodes of Kubernetes cluster, which is very bad idea because you are making the infrastructure or those nodes actually stateful. Because if the cluster disappears, then the data is gone with that. So ideally, in the perfect or in best practice configuration, you have your Kubernetes cluster or on your AWS infrastructure or some whatever infrastructure, and you have the data which is stored in data storage service, which is completely independent of your workloads on cluster. So now if the cluster basically just disappears, or it gets corrupted, it gets hacked in, or the infrastructure kind of blows up, you still have the data, and you have your Terraform code that can bring up that infrastructure very easily from scratch. So you can just plug in the data back to it, and the application continues running. If you lose the data, or it gets corrupted, again, stolen, or whatever, ideally you have the backup of that storage of the data. You have your Kubernetes cluster, which is running independently of the data. Again, you plug that in, do data recovery, and you're good to go. And there are actually tools. Because of the trend, people realize this is something that people have to manage manually now, and it also needs automation. So data backup and restore needs to be automated the same way. And there are actually tools, one specific tool that comes to my mind for data backups in Kubernetes clusters is K10. So basically they allow an operations or Kubernetes administrator to define the automated workflow or automated processes for regularly backing up the data, storing it somewhere outside the cluster nodes, separately doing the backups, and then if something happens, basically restoring the whole thing. So everything is automated in one flow. And you can tie that into Terraform and say, if you lose both data and the cluster, you can tie that tool, for example, with Terraform and say, bring up the whole infrastructure, connect data to it from the data backup, and you have exactly the same state, same cluster as you did before that incident, whatever happened. So again, there's a big trend going into that direction as well. And one more very important use case in terms of easily replicating your infrastructure with Terraform code is something that probably every project has. We have multiple environments, right? So multi-environment replicas is something super, where the usefulness of Terraform also becomes clear, because maybe you have, I don't know, development, testing, staging, and production environments for different purposes. So you don't want to go through setting up the infrastructure for each one of the environments using some manual scripts, obviously, right? So you define that once, the infrastructure, and that's another thing that infrastructure as code actually made possible was that having those environments identical to each other. Because before that, and you probably also know a lot of examples like that, dev environment would look very different from the production environment, which is actually not good because you want to test, the purpose of dev and staging and so on is to test on a production-like environment that the code is working so you don't have any surprises when you release it to the production. So Terraform or infrastructure as code makes that actually very easy to do because you have one like structure or one piece of code, and you can just pass parameters and saying, okay, this is going to be a dev environment, this is going to be a test environment, and basically replicate the same infrastructure on all environments. And you can pass parameters saying, okay, dev doesn't need so many resources, so let's do 2 servers on dev environment, and on production we have 10 servers, but the configuration and the logic is going to be the same. So that's obviously another advantage. And one more trend, which is also super interesting in my opinion, that kind of emerged as an extension of infrastructure as code trend is GitOps. So what happened here basically is with infrastructure as code, you have automation and version control, right? So operations engineers, Kubernetes administration, so whoever needs that, are working on infrastructure code, just as developers are working on software code, right? But developers have build and deployment pipelines for their code changes. So when they commit the code changes, pipeline will run that will test, build, and deploy that code or those code changes automatically to the end environment. Now, without such pipeline in infrastructure as code, you are kind of breaking the automation at commit, right? Because now so you have basically made those changes in the code and you commit it, but who is going to apply those changes to the actual infrastructure, right? Operations will check out the code locally and then do Terraform apply from their laptops. And then when the changes are applied, then they have to go to the infrastructure and check, is everything fine? Is the application still running? Is infrastructure still intact? Nothing's broken. So you basically introduce that manual process again. So you're not end-to-end automating. And again, Terraform has state management. So when you execute change script, it just applies those changes by comparing current and desired state. So it basically helps you with that. So you can execute the same code multiple times. You always get the same result. However, after we applied those infrastructure changes, we, again, as I mentioned, have to check that everything still works. We didn't break anything. So this part is something that could actually use some automation. So that's where actually GitOps concept kind of came in to say, since we are already using the tools that developers are using, which is version control, automation, and leveraging that to write infrastructure code, let's actually add a pipeline to that does the same thing, right? That basically takes the code changes and applies that to the infrastructure on development or whatever environment you want to apply those changes to. And you can even go one step further and say, I also want to test my infrastructure changes before they go to the environment, just like you would do for your software code, right? And there are actually a lot of tools that let you write, automated tests for Terraform or Gloomy or generally for infrastructure as code, and even tests that let you test the changes once you applied the infrastructure adjustment to make sure that everything still works. So you kind of have this integration testing for your infrastructure. And adding that pipeline to the automation plus version control, the whole combination is actually GitOps concept, which I think is super interesting and kind of naturally extends the whole automation process. And again, there are lots of tools, especially in CI/CD area, that kind of tie into that GitOps concept that already are, like, you have Argo CD and some alternative tools actually that help you do that. And also to mention, GitOps is the concept actually kind of tied into the Kubernetes technology. So most of the tools, most of the GitOps tools are actually optimized to work with Kubernetes. So you have an agent in Kubernetes, and then you have the whole workflow of CI/CD pipeline connecting to that agent in Kubernetes cluster and taking over the infrastructure changes. Or in case of platform changes, or in case of infrastructure, you have that tied into Terraform code, for example. So I think it's a super interesting and super interesting trend. As part of, there is also a concept of network as code, but I would say this is this can be part of infrastructure as code, because you can also make any network configuration within that infrastructure definition in Terraform. So for example, if you're on AWS and you need to configure network for your Kubernetes cluster, or just for bare servers, you basically just define that also as AWS resource configuration in your Terraform code. And the next interesting concept, probably next to infrastructure as code, that also emerged was configuration as code. And the reason for that, and that's probably that's where a lot of questions actually from people come in. Why can't Terraform just do the configuration? So this is basically how the whole thing works. So with Terraform, we said that we automate infrastructure. So if you are tying to AWS API, basically you get access to all the resources, and you can leverage the state management to make the infrastructure management and provisioning easy. When you provision a server, so once the server is created, Terraform can't actually see within or inside the server anymore. So that's kind of where the Terraform magic stops, is with server configuration. So for example, again, let's say I want to set up my own Kubernetes environment from scratch. I'm not using any service. So I have those servers. I need to install Kubernetes binaries on them. I need to install container runtime. So I need to install these packages on the server. Terraform cannot actually do that, because Terraform can see inside the server. So you could actually pass a script, a shell script to Terraform saying, execute this script, install this. But Terraform doesn't, you can't leverage the state management of Terraform anymore. So you kind of have to rely that the script executed successfully. So you have to, again, go and check. It doesn't give you any error or success message on that part. So it doesn't have visibility there. That's where another tool, which is the most popular one being Ansible, but there are actually other popular ones like Puppet and Chef, which are dedicated for this use case, right? So once the infrastructure is provisioned, now a tool that actually has a visibility into the server, such as Ansible, can be used to automate the configuration part of the servers. So with Ansible, again, you can do all these things that I just mentioned. You can install any binaries, any packages. And what Ansible brings to the table, or any other configuration as code tool, is the visibility into the server and the state management. So just like Terraform has state management, and it tells you the server is already running, this is the IP address, this security group is already configured with this, and this. The same way Ansible can tell you this package, Docker is already installed on the server. The Kubernetes binaries are already running, so you don't have to make those checks. And the same way Ansible is also kind of idempotent, not 100% in all cases. But if you're leveraging 100% of the state management in Ansible, you can execute the same code and you get the same results, which is main difference between Terraform and Ansible is server management, and that's where it comes that a lot of people ask in projects, engineers that I'm actually consulting, is Ansible can also provision infrastructure. So why don't I just use Ansible for both? So I have the one tool for creating infrastructure and then basically configuring that. So the question to that is actually similar or same that I just mentioned. With Ansible, you can actually create infrastructure. So if you're using this AWS library or module in Ansible, you can create servers, you can configure everything that you can in Terraform. But for infrastructure provisioning side, you don't have that kind of state management, so it's not as easy as with Terraform. So you could theoretically do that, but it's just easier with Terraform. And again, this kind of is parallel to with Python, for example. You can do everything that Terraform and Ansible are doing, but it's very low level, and again, you have to check everything yourself, just like in a shell script, for example. And that's why we want to leverage tools that give us additional features to help us with mostly state management, so we don't have to define every single detail ourselves, and it kind of helps us with the infrastructure management, the tool itself. And one very common use case, and something that I've actually used in a lot of my projects, is the combination of Terraform and Ansible, which is logical, right? Because you provision a server and you want to do something with that, and ideally, install something and configure something on that. So you can actually have a handover. So Terraform basically provisioning the whole infrastructure and then handing over to Ansible, saying, okay, now you can go ahead and configure the servers with whatever you want. So that combination is actually very common and very powerful, and the integration is super easy because you can execute Terraform Ansible scripts from Terraform. And one more thing that I also got asked from the engineers is, since Ansible is code, Terraform is code, a lot of people ask, do I now take this code and edit it to the same repository where I have my application, because it kind of related to my application, right? So I have infrastructure and its configuration for my software application, whatever I'm developing. So do I kind of have that in the same repository? And do I use the same pipeline for both of them? And the best practice there is actually to completely separate them, to have your code in its own code repository and own pipeline dedicated for that, and have Terraform and Ansible, or even those two, kind of split in separate repositories. And the main reason for that is because the life cycles of those are completely different, right? So you're not provisioning a server or changing something in your server configuration every day, but you may be releasing or building your application multiple times a day. The same way, you are maybe not provisioning server as much as configuring your infrastructure, right? So it always makes sense to divide the code and the pipelines, especially based on the life cycle, how much or how often these things change. Because if you put them together in the pipeline, then you have this complex logic of this, deciding, build this only if the code in whatever related to Terraform changed. So it just makes the workflows and the whole process way easier and just cleaner to divide. And another reason is that in many cases, you probably will have a separate team working on Terraform or Ansible, and which will be maybe operations or systems administrators or Kubernetes administrators, and a separate team of developers that are actually working on the code. So splitting the repositories and pipelines is actually best practice. And finally, some honorable mentions of excess code is security as code and policy as code. Security is something that very often gets ignored or not very, a lot of engineers don't really pay attention to that, and not because it's not important, but because with the introduction of DevOps and Kubernetes, it already became so complex that, like in my opinion, probably became just too much to also think about security, which is obviously really bad because security should not be an afterthought. It should be basically part of the whole process. And it's, in terms of security as code, it's a little bit tricky to talk about in example and details because security, you have security on many layers, right? You have security on infrastructure level. You have security on the platform level for Kubernetes, right? So you have the Kubernetes security is its own area, basically. And you have security in your build pipeline, right? In your containers, for example, are you creating and building images that don't have any security issues inside? Are you scanning them and so on? And then you have security on the application level. So for each one of those levels, you may actually have different tools that help you with integrating security as code in those layers. Another one that is super interesting and important is policy as code, especially when working with Kubernetes. So in practice, what happens is that Kubernetes administrator or operations team would configure Kubernetes cluster and make it available for developers and let them basically use that, right? So in order to avoid the overhead of managing multiple clusters within an organization, you would have one team that creates this big cluster. They are in control of the control plane, and developers get kind of, each team of developers gets access to a chunk of that Kubernetes cluster, of the same cluster. And in order to separate those teams from each other, the Kubernetes administrators have to create namespaces and create resource quotas to make sure that developer teams, so one developer team doesn't use up all the resources and leaving the other ones kind of without any resources in the cluster, or they don't kind of mess up with other teams' resources. So you have this kind of separation. So each developer team gets their own kind of space. So they don't see the other spaces and they can't break them. So now developers can deploy Kubernetes components within that namespace. Usually or ideally, this should be in the pipeline, right? But what happens is that when developers misconfigure the Kubernetes manifest files, for example, they set root user for pod containers as a workaround for some case, right? Or they do not define resource limits on their pods, which means one pod, if it has a resource leakage or if it has some bug inside, it may actually use up all the resources in the namespace, so the other pods will be evicted. Let's say operations wants every developer team to use network policies for their services in order to increase security in the cluster. So operations may have these requirements from the developers teams, but the developers may not be so knowledgeable in Kubernetes, which is what we often see in practice. So they don't have as much knowledge as the operations, so they may accidentally, without their knowledge, actually misconfigure those manifests. They may introduce some security issues or some resource management issues. So what happens is pipeline deploys that misconfigured deployment configuration file in the cluster. It runs successfully. You don't get an error just because it's it has a security issue in that because there's nothing checking it. So how can operations make sure and check that every deployment, every Kubernetes manifest file that is coming from the developers of the pipeline is secure and valid enough and basically matches their requirements of what needs to be or what can be deployed in the cluster. Again, we have this manual repetitive work. If they have to go and check and inspect basically every single deployment that developers or pipelines are doing. And that's where the automation part comes in as policy as code. And there are tools that let operations define a policy, like there can be a pod container which is run by a root user, or each service has to have an associated network policy, or pods must have resource limits, whatever, right? They define those policies in that tool, whatever that is, and that policy tool then takes the deployment or the Kubernetes manifest that is being deployed into the cluster, takes the policy that operations engineers created, compares them, and it sees if the manifest breaks the policy, it basically gives an alert. Very, very common way of integrating that or using that is actually defining the policy as code in the pipeline itself, integrating it in the pipeline to act as a gatekeeper. So for example, a policy as code tool, whatever that is, because there are a bunch of them actually for Kubernetes, is running as an agent in Kubernetes. And when pipeline tries to deploy the misconfigured Kubernetes manifest files in the cluster, the agent checks that. And if it breaks the policy defined by operations, the list of policies that it has available, then it rejects the deployment and the pipeline basically fails. And this way you can automatically gatekeep what gets deployed into the cluster. And operations teams can actually use that to prevent any unknowledgeable or engineers who don't have enough knowledge of Kubernetes of deploying misconfigured stuff in there. And it's also good for developers because they now immediately see that there is an issue with their configuration, so they have to fix that. And operations save the manual inspection effort in this case. So basically, as you see, the trend is going towards automation. And every time a task is detected that is repetitive, which is error-prone, which is done manually, is a good candidate for automation. And engineers' main task becomes writing those automation programs instead of doing the things that the automation program will then take over. And obviously, the challenge with this is learning all these tools and using them in your projects, because whatever, if it's a policy as code or security as code or infrastructure as code, you actually have to learn those tools. You have to learn how to use them, and then you'll be able to use them in your projects. And now it kind of seems like for every single use case, there is a dedicated tool. So hopefully there will be kind of consolidation of that. Instead of having 10 tools for 10 different use cases, you can leverage 2 or 3 tools basically for covering multiple automation use cases. So that's basically the trend that I'm seeing in terms of all the tools that are being developed and the concepts that are becoming popular and kind of hyped. So yeah, that's, I hope I was able to give you some interesting insights and you learned new things about this concept and trends. And that concludes my talk. Back to the organizers.
So thank you very much for an interesting talk. I think for those who didn't know that many details and insights about automation tools like Terraform, Ansible, their purpose, how and where they need to be used, and what are the appropriate places and cases of their usage, they learned a lot. So if there are any questions, you can directly pass the microphones.
Yeah, it's of course me. Hi again. Nana, this is Tigran from Armenia. And first of all, I want to make appreciation to you, and I think guys from Armenia will join me, like for the all educational stuff you are doing and sharing with the community. Like it's a huge thing to let people learn new technologies and do their best. And my question is, you talked about the concept of automation like a couple of years ago, so most people didn't know about the infrastructure as a code, GitOps, GitSecOps, etc. What do you think? What would be the next step of the infrastructure automation, and or do we have any part of infrastructure that will be the next to move to the code? Thank you.
First of all, thanks for your appreciation and kind words. I'm very happy to hear that. And yeah, so in terms of infrastructure as code configuration, as I mentioned, I think the next logical development would be to have the possibility to not only provision infrastructure, but to also configure it. in terms of like inside the servers, because it is kind of effort to use 2 or 3 tools for covering the use case that you always have. One thing, this is actually something interesting that, so one of the companies from Silicon Valley actually contacted me a couple of weeks ago, and they're working on network as code, right? So this is kind of the next step to the whole thing, because networking is something that hasn't been as automated and configured, because even with infrastructure as code, you still have to work with the VPC and subnet and security group and so on. Or, for example, that's a networking on the infrastructure level, but then you have networking inside the Kubernetes cluster, for example, right? Which ideally, if everything works, you don't have to deal with that. But if something breaks and you need to troubleshoot, then you have to understand what's going on inside there, right? Docker networking, Kubernetes networking. So they are actually they already have the first release of their tool, which basically lets you define network as a tool, network as a code, but not only for like AWS or Kubernetes cluster, but for multiple clouds, for example. So you can use it in hybrid. And you can define network on a logical level. So for example, if you have a database server on AWS and you have another database server on Google Cloud and one on on-premise, because of failover optimization, you can actually put them all together in one logical resource, saying this is a database on all these different platforms, and you can define that as a code, kind of skipping over all the networking configuration, using that tool that completely abstracts the network configuration. So I was actually really interested to see a couple of other use cases that they're seeing with the tool. So this probably can be the next thing in DevOps and generally in the infrastructure area.
Thank you. Thanks a lot.
So maybe I will ask one more question. So everything, basically, when DevOps engineers are dealing with Terraform as a tool, and approaches and the mindset is changing, and then everything, and you would like to do, and you have a tendency to write the code to manage the infrastructure, right? So my question is, what would you recommend? I mean, is it the same efficient modules are available for the on-prem infrastructure as for cloud, or can we say that the on-prem infrastructure Terraform modules are basically dying and they will be drained soon, and we will start working towards cloud completely? Can we have? Yeah, that is a very good point actually, and I have had one example where I tried to use Terraform for not so popular cloud and also on-premise, and to be honest, I mean, it does have the benefits, but it's definitely not as optimized as for the popular clouds, for example. So I believe that Terraform's idea, or they're kind of already leaning towards the trend that everybody's moving to cloud, so there's not going to be that much need for on-premise configuration. And because I know that they are developing the modules and improving the modules for AWS and for other cloud platforms, but I haven't seen many such improvements for on-premise configuration. And I actually know a lot of people, because of that, they use Ansible for provisioning infrastructure on-premise, because it is easier. I mean, it doesn't have the state management, but it's still easier than Terraform, because then Terraform actually has way more limited functionality for doing that on-premise. Thank you. And maybe one more thing. So when you are trying to marry Ansible and Terraform in the pipelines with management, so what would be the best practices, just in few words? So I think with that we are already going to the site reliability engineering, right? That's why that has emerged, and we'll have a great speaker about that as well, but it would be also good to know your point about that.
I actually asked that question to the Ansible engineers team when I was kind of researching that. And basically their answer is that they see customers or people who are using Ansible use it in completely different ways, and they didn't have a best practice. I was kind of trying to play around with it and kind of see what is the most, first of all, easiest, and the second one, the most solid, like unbreakable way. It is like generally it's very easy to combine them because you just have basically within Terraform you have this module that lets you pass on the control, so to say, to the external script, and that script can be Ansible. So you can just execute Ansible playbook directly from Terraform, and basically that seems to be kind of the best practice. You could do that remotely, so you can trigger from Terraform the Ansible agent remotely, then kind of configures other servers. But as I said, like according to Ansible engineers, a lot of their customers, people who are using Ansible, use it in various different ways. But this is the one that I found the most easiest and less complicated, just to hand over with just a script execution from Terraform to Ansible, and basically that's it.
Thank you very much, Nana. It was a great pleasure to see you here. Next speaker will be Marina Kudryavtseva and Vakhtang Donadze, right? And the topic is extremely interesting. It's about software testing. It's about software testing for the NFT-based marketplace.
Hello, everyone. And first of all, thank you, all of you who stayed with us to listen to our presentation. Let us start. Just let me. OK. So my name is Marina Kudryavtseva. I'm head of DLT division at ExactPro, and I oversee DLT-related work across ExactPro projects.
I'm Vakhtang Donadze, and I work as a Java developer at ExactPro, and for past 2 years I've been working on the project which is called TH2, and quite a big part of the presentation will be about this project, so we will dive into it later.
Yeah, just briefly what we are going to discuss today. We would like to present our automation approach, and this approach is implemented using our automation framework, which is called TH2. So we are going to present this tool and describe how it works, and we will also provide some of the examples, examples of actual implementation, how this tool works, and we will consider one system and 3 examples. ExactPro provides independent software testing services for mission-critical infrastructures. We are focused on functional and non-functional testing for financial market infrastructure. We perform testing for settlement, clearing, trading systems, DLT-based systems, and other systems. And today we would like to talk about our recent work, which has been done in collaboration with a Yala Labs company. The company developed a platform which is called P8. And P8 platform is a blockchain-enabled solution deployed on a cloud. It helps innovators launch marketplaces for cryptocurrencies, security tokens, non-fungible tokens, different traditional and digital assets, and others.
I think I'll join now about TH2. So in general, TH2 is an open source testing framework which can provide end-to-end functional and non-functional testing for complex automated distributed financial systems. Such systems can be security exchanges, brokerages, banking systems, or even NFT marketplaces. And the important thing about TH2 is that it is a microservice architecture based on the Kubernetes solution. And while listening to the previous presentation about the best approaches in DevOps and microservices, I was thinking about myself, okay, we have that, and we are working on another thing. So it was a quite good self-validation to know that we are moving in the right direction in our project. So let's see about TH2. Another important thing in TH2 is that we have unified data storage, which means that every testing and every test scenario that runs through the program is saved into database, and it is accessible later during the project lifecycle at any time. So no data is lost when TH2 is working. And we are saving two kinds of data in our database. The first kind is messages, which is shown by the blue line. It is the data that is actually sent to the system. This can be requests, this can be responses from the system, what was actually performed and what data was sent to the system. So we are saving that, and in addition to that, we are also saving another kind of data which is called events. So events are the messages that are generated by each step of the TH2 process. So as it is a microservice architecture, we will have many different components, and each component, when the message goes through this component, will generate a specific kind of event, so informing us that data reached this component, it was sent to another component. So basically, step-by-step execution of the test is also saved into a database. And as we provide unified data storage, it means that later this data can be accessed by some UI tools or data analysis tools that we have also developed. And we can analyze this data in a visual way. We can create some statistics. We can see some correlations and many other things that the UI and data analysis tools provide. So this is basic structure of the TH2 environment. As I mentioned, we'll have many different microservices running together, which are denoted as the white boxes. And we need to somehow connect those microservices so they can act as one testing environment. To connect these microservices and to enable communication between them, we are using two kinds of communication type. We are using RabbitMQ for messaging brokerage, and we are also using gRPC requests between some of the components. All these components are then connected to the system under test, which receives the messages and the responses. And as I mentioned, we again see a Cassandra database, which saves all the information that is happening throughout the testing lifecycle. To arrange those components into these nice schematics, to enable communication between them and to configure how many of the components we are using. Well, for example, to remove one of the components, to add another component, we have developed a separate layer which is called infra layer. Basically, it is just a management tool to configure the testing environment and to allow users to edit this environment quite easily and just with a simple configuration. And on the left, I think on the right side for me, you can see the source codes and the Nexus repositories. Basically, source code for every component used in the TH2 is saved in one of the Git repositories. It can be GitHub or GitLab, depending on if it is open source or not. So when the code is saved in the GitLab or GitHub repositories, we have enabled pipelines which automatically transform this code into Docker images on every commit, on every change. Later, those Docker images are uploaded into Nexus repository, and once the new image appears for a specific component, it is automatically updated on the cluster. So to edit one of the components, it's just enough to commit changes to the code, and the whole rest of the process is automated and done by our microservices. So I think this is quite interesting side. Here I want to talk about what kind of technologies we are using in TH2. We have listed quite some options. So the highlighted ones are the options that we would use for a demonstrational deployment, like quite easiest one and most common ones that we would use to just show the TH2 to our client and just to show how it works. We can start from the hardware. So we need hardware to run everything, and hardware can be anything in our case. It can be bare metal, we can use some private clouds, but mostly we are using public clouds at Amazon, AWS, and Azure. After that, we need some operational system to run on this cloud, and I think Ubuntu is the easiest choice for us, but we also support all other operation systems. Basically, there are no limitation in this spectrum. The next layer is data storage, and for TH2 we are only using Cassandra database, so it's quite a requirement, and this one is not optional. And after that, we need some container orchestrating tool. We can work with vanilla Kubernetes. In most of the cases, this is how we work. But recently, we also start supporting some of the private Kubernetes deployments such as OpenShift. We can also work with the VMware Tanzu deployment and other managed Kubernetes systems. For the next step, we need some repository to hold Docker images. This can be like public registry such as GitHub image registry for open source images. And for example, for the proprietary images that Exapro is developing, we are using Nexus repository for more security. Next layer is the communication between components and communication to the cluster itself. So we are using RabbitMQ for components to communicate with each other, and we are using Nginx ingress controller for users to communicate to the cluster of the Kubernetes. The next layer is the infra layer that I mentioned, which allows us to manage our deployment and manage the resources that we are using on the cluster. And later we also have actual TH2 components, the actual microservices that we are running on this cluster. Again, we can have open source resources. So basically, we can run TH2 using just open source resources. Every core component of the TH2 is open source. So we can perform functional and non-functional testing using just open source resources, but we are also working on our proprietary resources for specific kind of testings, which was, for example, requested by the user, and such kind of resources we are holding on the GitLab. And we also have cases when users are developing components by themselves, and we can use these components too, so clients can have their own proprietary resources. And the final layer is the visualization. For this, our main tool is the Kubernetes dashboard itself, which is quite useful. We also have monitoring stack, which consists of Loki and Grafana and Prometheus for collecting logs, for collecting metrics, and for collecting the state of the components, how they are operating, if they are operating well or not. And we also have Jupyter notebooks for analyzing data which comes from the database. So we are using Python for machine learning and data analysis. So now let's talk about how our QAs and our users can configure and use TH2. For this, we will need Kubernetes cluster and we will need Git repository. On the Git repository, we will have configuration files. We can have many different branches on this Git repository, and each branch will represent a specific testing environment dedicated for its specific purpose. So we are not restricted in how many branches and how many environments we can have. It can be like 3, 5, and more. And each of these branches will later be transformed into a Kubernetes namespace, which will actually have the components running in it, which are just basic copies of the files, like results of the files that we are holding on the Git. On this slide, we can see what kind of configurations we are holding on the Git. So we have several folders, and each of the folders contains YAML files for the component description. So each file that you will see on this slide is basically description for one specific component. And for this, we created our own custom resource kinds, which abstract and make easier for regular user to configure only the necessary stuff that user needs to control. Later, these config files are analyzed by our tools, and they are transformed into Kubernetes components such as deployments, config maps, services, and so on. So we are trying to make it much easier for user to make the configurations. And of course, we also have users which are not comfortable with Git and YAML configuration. So for this, we developed our own UI tool, which does the same thing as the Git before. So again, we have files here, and these files are represented as nice UI in other tool, and they are both for editing and constructing the testing environment. And now we can move to the studies itself and cases in which we have used TH2.
So first, let's consider and let's see how TH2 can be used to perform reconciliation tests. Reconciliation testing is used to ensure consistency between two different transactional data streams. Its main goal is to validate that each request has its corresponding response with a proper data. As input data, we can use the results from different testing activities, such as exploratory testing, regression testing, functional, non-functional testing, random load, and others.
Well, now let's see at the configuration for TH2, which was used to perform reconciliation testing. Here in blue, we see some of the basic components which probably need to be used in every TH2 installation. So to start testing, we need some test script. And this starts with the testing scenario, which is the rightmost component called test scenario. Here we have either Java, we have Python, we have Kotlin test scripts, which can be then sent to the TH2 system. The first component that the script interacts to is called act component, which will translate this script written in Java into messages and events that is appropriate for TH2. Later, those messages and events are sent to the codec component, and codec component is the one that will translate those messages into a language which is appropriate for a specific system. So as we are working with the financial systems and exchanges, there are some alternatives messages that they use. For example, it can be fixed, it can be native, it can be fast. So different systems may use different languages. And for that, we have a specific component codec, and just by changing this one component in the whole system, we can adapt to another system. So the rest of the configuration can stay the same. We just need to change one microservice to change to the different system. And finally, we have a connect component, which is responsible for maintaining connection to the system itself. This can be a REST connection. We can use WebSockets. We can use, again, gRPC and RabbitMQ. It also depends on which kind of connect we are using. And now we want to extend this basic configuration into one that supports reconciliation testing. For this, we only need to add two components, which are called recon for reconciliation testing and book checker. So we can reuse the basic structure of the TH2, of the testing environment, and just add additional components to perform different kind of testings that we want. And again, we are having database and UI tools to monitor the testing results.
So like we have mentioned, so our system under test for these examples is the P8 platform, and P8 includes a native crypto wallet, and it integrates with different third-party wallets such as MetaMask. So the platform is integrated with the key public blockchains networks and the Corda private distributed ledger. So let's consider a functional scenario, which is non-fungible token transfer. So what happens here? User 1 with a crypto wallet account gets authorization on the NFT marketplace and creates an asset. So this asset then will be deployed on the blockchain network as a smart contract and will be listed for sale with a fixed price. User 2 will purchase the corresponding NFT minted by a contract.
Again, we can see what kind of environment was used for this. So here we see just the basic environment without recon and book checker, because now we just need to perform functional testing. So again, we have the main components, which are act, codec, and connect. In this case, we need to add additional connect component to connect to the blockchain network itself. So we just reused basic schema and just added one more component to perform functional testing. And we will cover this example in our demo video, and we will show actual test run and how it changes the platform and how we can see the results of the test run.
The last but not least example is formal verification of smart contracts. For this NFT marketplace, so we had a source code of a smart contract, and we decided to apply this kind of verification. So formal verification is a white box syntax technique. Therefore, if we want to run this kind of check, we need an access to an actual smart contract source code. And the main goal of this testing is to identify issues in the smart contract itself. In our case, we have used a set of open source formal verification tools, different in terms of verification types, methods, and levels. So we have used two tools. So the first one is SMT Checker. SMT Checker is a formal verification tool which is integrated into a Solidity compiler and allows the one to automatically validate that the certain part of code meets a certain specifications using mathematical techniques. And the second tool is Manticore, is a symbolic execution tool for analyzing bytecodes and smart contracts. And so here are some of the examples of formal verification workflows. And this particular one is for the case when we used SMT Checker. And what happens here? So first, we need to create a formal specifications. And normally it's created by an expert, some person. And these formal specifications should be expressed in a language whose vocabulary, syntax, and semantics are formally defined. Then the source code with Ethereum virtual machine bytecode and this created formal specification are processed by a static analysis tool. In our case, it was SMT Checker. And then we get a result, and we need to take that for further analysis in order to make a verdict.
And again, this case is a bit different from the previous two because in this case, the testing itself was performed by Manticore and SMT Checker, so additional tools. But we can still reuse part of TH2. We can reuse the report UI and data analysis part to analyze even the results performed by other checkers. In this, we created the additional special component, which is exported plugin. It will receive the data generated by the additional checkers, by the third-party checkers, and it will translate this data into TH2 type events and messages. Later, they are again saved into database, and we can reuse our UI and data analysis tools to even analyze data which was generated by some third-party components. And I think this was end of the slides, and now I want to show you the video demonstration. So here we are starting with our script, which will okay, so I will be just commenting over the video, so I will explain what is happening. We are having a configuration for the test which we are going to run. Here we are defining some of the global variables, which are the wallets for the user 1 and user 2. And below we are defining the parameters for the asset that we are going to put on the blockchain, and later user 2 will buy this asset from the user 1. So we define the wallets for each user, and we define the parameter for the asset itself. And below we are having some of the important functions, which are the steps of the execution. So first we need to create the asset itself. So we are creating the asset, we are creating the collection that will hold the asset. So these two methods are just creating those assets and collection. And later we need to deploy asset on the platform. So we are deploying asset in this part. And in the next part we are listing asset for the sale. So one step is to deploy asset, and another step is to list it for the sale. And as the asset is listed for the sale, finally user 2 will perform the buy action, and we can see that it was actually transferred into second user's wallet. So we will soon run this script, and we have some breakpoints on the essential parts, and in parallel we will see the P8 platform itself, and we will see the changes in the UI and changes in the platforms that happen during the breakpoint executions. So the first breakpoint we see at the deploy asset step. So by this step we should already have the collection, and we should already have asset created on the platform. So once it runs, so this is the P8 platform, and here we see that collection is created, and we see that asset is created. But for now, there is no parameters and no information about the asset because it is not yet deployed and it is not listed for the sale. So we will go back to the code, and we execute the next breakpoint which deployed the asset, and now when we check we see that it is deployed on the Ethereum network. We see some specification and information about the asset, but we don't have the price yet because it is not listed for the sale. So next step is to perform another breakpoint to move further and to list asset for the sale, and after this, the refresh, we see the price for the asset. So it is listed for the sale. Now we will switch to the window for the second user, and here we can see that second user is able to see the asset, but it is not owned by the second user. And after we execute the buy step, we will see that new line will be added here, and we can see that asset is now minted, and now it belongs to the second user. So later we will move to the wallet of the second user, and we will see that asset actually is transferred here, and we can see that it is owned by the user. And now we see the report UI tool, which is developed by Electro, and in this tool we can see the report generated by the text execution. So here we see different events that were generated. We see every step of the execution. We see every step, every component's event. When we open one of them, we can see the comparison table containing the actual and expected results. We can see that everything that we expected is matching with the data provided by the system, and we have additional window which shows actual messages and data that was sent to the system and received for the system. So by highlighting one of the events, we are automatically highlighting the message that corresponds to this event, so the kind of data that was present in the system during this step of the execution. Basically, this is end of our demonstration, and we are ready for the questions, if there is any.
Okay, so can you elaborate on the KPIs of your testing tool? So what exactly you deliver to the user, to the platform with this tool? So what are the benefits that they can gain?
Oh, it's too loud, sorry. Yeah, of course, when we look at our testing activity in general, so first with each system we want to learn about the system, when we try to identify some kind of coverage which we want to do, and then it goes to automation, and we would like to automate as much as we can, and that's where TH2 comes up. And what our main goal is to automate first, for example, the regression library. So in order to execute testing as fast as we can, in order to provide a result to our customers. So that's the main goal, to do it fast, but on the other hand, with a good quality.
Okay, so yeah, actually I was trying to understand if it helps to guarantee some kind of security and kind of make the entire platform more kind of prone to some threats in general. but I think this is the feature of the entire background technology, right? What you are using.
Well, yeah, the security is a separate part, so it's, I would say it's a subject for security testing, which is performed by our tools, which is well known on the market, and we do not target the security testing by our tool. It's mostly functional and non-functional testing.
Mm-hmm. And I also wanted to ask you about the scaling. So what is the largest scale you can expand your framework?
It depends.
And how the scaling works. That's the main. So how exactly you implemented this?
Okay, so basically we are not limited in the scaling. It only depends on how much user wants and how big of the environment is user going to sacrifice and provide for us. From our side, we can just add as much components as we want. We just need to add one more file in the Git repository, and it will automatically add another component in our ecosystem. Or we can just increase the replica number, which is also done through Git configuration. So scaling is not a problem as long as it is requirement, as long as it is needed.
Okay, so doesn't have that auto-scaling feature. You said that basically it's backed by Kubernetes, right?
We don't provide auto-scaling because we are performing tests which are already planned, and we already know what kind of resources are needed for this kind of testing. And if there is a new kind of testing requested, we just recalculate the resources. We see if there is need for additional resources, if there is need for some more component, and then we decide if we want to add or remove some of the components. The process of adding is quite simple, just editing the configuration file, and the rest is automated. But generally, we are working with a pre-configured size and pre-configured scale for kind of testing.
Thank you. Okay.
Thank you.
Okay, great. Thanks. Okay, so we're going to have a coffee break now, right? Charged with caffeine, refresh yourself, because we will have two more very interesting speakers talking about SRE, and actually three really interesting speakers talking about SRE practices, AWS best practices for organizations, and an interesting speaker from EPAM Georgia. EPAM Georgia, right? AWS well-architected business continuity and disaster recovery. So
David's speech is about getting started with SRE. So he will be talking shortly. Thank you.
Hi everyone. My name is David. Before we get started, I would like to announce winner of a quiz that was conducted earlier. Saba Sakwarilidze. Yo, where's the bag? Nicely done. There's some good stuff inside, and for anyone else who wanted to win something, there's going to be a similar giveaway tomorrow. So, yay. All right. So my name is David. I'm working at DataArt, and today I'm going to try to introduce you to something new, and hopefully at the end of the day you're going to have some new search keywords to add to your job search, or just new stuff to explore and learn. So ever since man plugged something into electricity, like the #1 way to debug, so to speak, or solve any kind of issue with it was to, turn it on and off. For some reason, this is not working. Nice. Yeah, problem #1. Nice. All right, yeah, so this was the #1 way humans solved problem with stuff plugged into electricity. Well, this kind of worked for a while. Well, that's embarrassing. This is also embarrassing. Well, if this happened with a real product that was
as global as the typical products that we are used to, like Facebook, Google, or Netflix, or similar stuff. Obviously, customers would not like this, and given how reactive today's market is, how sensitive it is to stuff like this, the stock price would definitely be impacted. So smart people at Google at around 2003 decided restarting things is not the way to go. They decided to give form to troubleshooting and fixing issues in production, and that form was site reliability engineering. The name comes from the initial purpose of site reliability engineering was to keep Google's sites running, and hence the name. Today is much more involved because obviously Google has become a monster, and today it's more about service reliability. So today we're going to be briefly talking about how SRE came to be, what problems it solved, and how. We're going to go over some specific details of what concepts are introduced to solve said problems. And we're going to also be taking a look into a mind of an SRE. What type of people are SRE engineers? Whatever mindset do you need, how they handle incidents, and what happens after the incident is handled. So, as said, SRE came to be as a unit within Google that was dedicated to making sure that their services were up and running all the time. So before we start talking about that, let's take a look how things used to be before DevOps, before SRE. And what I'm about to discuss is going to be very familiar with for people who work with DevOps. So there used to be two camps, ops and devs. They all had their own goals, mindset, and agenda. So the ops folk was where if it ain't broken, don't touch it. And the developer folk were, oh, this button looks shiny, I want to add it to our product. And these were essentially competing ideas. Change, the new shiny buttons, they bring change, and change is what breaks things. And ops folk inherently didn't want things to break because that was exactly their task, to keep things running and to keep things not broken. So to eliminate this competition of ideas, SRE aims to bring collaboration between these two camps. So the idea behind SRE is let's align these goals so that ops team and dev team, they serve a similar goal. So this requires a shift in mindset on both teams. This means that reliability and operational excellence becomes a day one goal, and it becomes a proactive thing instead of retroactive. And the challenges with these were, first of all, the operational folk back in the day, so to speak, they used to be as far away from the corporate centers as possible. They were in data centers, and their job was to put out fire before emails reached C-level suite. So developer camp that used to be much closer to corporate buildings, and maybe they even worked there, they were kind of far away from this problem. And developers would just create some feature, put out the code and throw it over to the ops side and, hey, go deploy this. Ops team had no visibility inside the code. They had no awareness what these features were. They had no idea how things worked. And this is a very familiar problem that is also discussed and solved in a DevOps culture. And this is breaking down the organization silos. And this is probably very familiar to you. There was also another thing that is very similar to DevOps culture. Before, in the olden days, the changes, their size were kind of large, and introducing this large change that has been in development for a long time, it had a high cost. So if something went wrong, introducing with this large change, you had a massive outage, massive fire, everything is on fire, everyone panics, and it was bad. So SRE and as well as DevOps culture, they and Agile, they decided to sort of introduce these changes in small, manageable chunks. And this is the type of workflow that we're familiar with today. And with outages, the challenge was that most of the time, nobody thought about accidents until they happened. Obviously, as a software engineer, as an engineer in general, you try to mitigate as much as possible beforehand. But this was not set as an explicit goal. This was something done retroactively. And all of these needed to change, and just like in parallel with DevOps, the SREs changed these with, as discussed, like with reducing the organizational silos, small gradual changes, and reliability becoming number one goal, day one goal. So let's introduce some concepts of how these are done in practice. Number one thing that facilitates the shift in mindset is the error budgets. But before we understand what error budgets are, we need to understand what is an SLO. To understand SLO, we need to understand SLI, SLA. So let's go over these concepts. So SLI, in its essence, is a simple idea. You take your service and you assign some kind of metric to it that determines that this service is healthy, that this service is available to users, and that's what's number one and most important, right? Our product being available to users. Our systems might be under heavy load, they might be generating some kind of errors, but as long as the service is available to our users and it's functional, that's what matters. We can solve other problems during the business hours, but we don't have to wake up in the middle of the night. So SLI is a metric that determines how healthy a service is. It can be a latency, it can be a throughput, or any kind of metric that engineers would devise. So, well, we have this metric. Now we introduce SLO. SLO is a threshold on SLI. So it's a line drawn on a graph that determines if this metric goes above the line, we need to wake somebody up. There is something wrong. If the metric remains below the line, then everything's fine. There is no problem. It's important to also mention that SLO is very deeply tied with the time frame. So you have SLO within a given time frame. So you have this 1 month period, 1 year period, maybe 1 week, and depends. Okay, we drew the line on the graph. That's very nice. But we need to have some kind of agreement to act upon the disruption of this line. So that's where the SLA comes in. You might have heard this term in other places. SLA is a very common term. In most cases, it means agreement between companies, service level agreement, that's the name. And if a company is providing some kind of service, it says, all right, I'm providing the service, I'm gonna have some kind of availability on the service, and if I don't make it, and if I don't manage to deliver this service within these parameters, I'm gonna reimburse you with some kind of, I don't know, it's either money or maybe extended service or some other agreement. When it comes to developer teams, you can't do that. When you're obviously not gonna ask a developer to, hand over cash. You developers pay with their time. And that's how we arrive at error budgets. So how do we set reasonable numbers for these? How do we say how much availability do we want from a service? Like, if you saw this advertisement for an airplane, and would you fly this? Like, you would probably get some of the doubts of, like, why is there some missing portion of the percentage there, right? But this is taken from last year's statistic. We took that risk. So we don't need everything to be 100%. There is some wiggle room there. And this is airplanes, which can, determine like whether if you crash, you die. So we take some kind of risk with our life. Luckily, we are software engineers, and if something breaks, worst case scenario, well, depending on the industry, plane might crash, but most of us don't work in those kind of industries, so we are okay with taking a risk of having some kind of error page for user or something not loading or something missing. So we have this wiggle room, and that wiggle room is our error budget. That is what we can spend on introducing the change. That is what we hand over to the teams who are creating these products, and that gives the self-regulation of changes and fixing the bugs in the system. That introduces the shift in mindset that we discussed earlier, and it works in a following way. So we determined that we have some kind of percentage that we can have some kind of percentage of time or a metric, and with this percentage can be errors. So let's say we have 1 million requests in a month, and we have an error budget of 1%. So among these 1 million requests, within a month, we allow our service to have 10,000 errors. And if we don't have 10,000 errors, that means we have gathered some kind of budget that we can use to introduce a change, a breaking change that would have those errors and would fill that space up, but that would be okay because that's a calculated thing. We know that we are going to have those errors. Now, if we go above that, that means that our change is not stable enough, and instead of introducing new features, we go back and start fixing the system. And that's where the self-regulation of the team comes in. The developer team is in control whether they do new features or whether they spend their time fixing the broken system. And that's where the shift in mindset is. That's where the self-regulation, self-discipline is. Yeah. Basically what I just said. Now let's take a look on who are the SRE, what type of mindset do you need, what type of person do you have to be. It's not so different from just engineers in general, but it is very welcome to be of mindset that why should I waste time doing this when I can have machine do this? And that's the basic idea of SRE mindset. It's automating yourself out of the job, and I'm pretty sure you've heard about this as a DevOps engineers as well, because that's a very popular mindset for a DevOps engineer as well. We automate ourselves out of the job. You see toil versus code. Toil is determined to be a part of the job that is manual, that doesn't involve automation. The clicking through things is toil. So anything that you do yourself, and most of the time people find this type of work very boring. It's also not as interesting as writing code and having machine do some very interesting things. Organizations like Google, for example, they have a very specific limit on how much toil an SRE should be doing. Like there's a 50% limit, and if a project requires more than 50% of toil, that means there's something fundamentally wrong there, and there needs to be some change happening. So far, we've been discussing the proactive part of SRE. Now let's move on. As we discussed, the incidents are inevitable. We do have that 99% something there with a bunch of nines, but there's that small portion left there that means that incidents are inevitable, things are bound to break. We can't help that. So SRE tries to make sure that incident is handled in a very controlled fashion, a very scalable and predictable fashion. And the key the key ideas there are that we have to reduce the impact of the incident, because if something breaks, our number one priority is that customers should not be affected for too long, because that's what affects everything, mainly money, which is like number one for the companies. And once we make sure that incident is wrapped up as quickly as possible, next thing to make sure is that this incident never happens again, or is much more manageable than before. So SRE specifically have a very structured approach to how the incidents are solved. And it is derived from Federal Emergency Management Agency of USA, FEMA. They have incident command system, and that served as a basis for SRE's incident handling procedures that they have. The key components in this are the scalability of how this process can easily scale from small incidents to large incidents. There's a very clear separation of responsibilities in this, and a crucial component of this is a live incident state document that we're going to discuss. So the incident handling team is divided into several roles, and we're going to discuss that. Number one role is incident commander. Incident commander is a person who has a high-level overview of the incident. They have high-level state in their mind, and they are also charged with keeping the incident state live incident state document up to date. Everything that is happening during the incident, every action that is taken is going to that document, and then it is used for later analysis. By default, any other role that incident commander does not delegate to other team members is assumed by the incident commander. Next role is ops, operational folk. Operations team is the only team allowed to touch the system when the incident is happening. Other teams are handling their responsibilities, and operational team is the only team that are actually working on the system. Next, the communications. Communications team are the public face of the incident. They're the ones who send the emails. They're the one who decide whether customers should be notified of the outage, if it's big enough outage, or whether they should not be notified, and they just send emails to the C-level suite informing what is happening, and so on and so forth. They may be occasionally tasked with keeping the incident document up to date. And lastly but not least, there's planning. Planning is the long-term aspect of the team. They order pizza, and they also file bugs while doing this. And most importantly, if the incident is not handled in one rotation, they hand off the entire incident to the next team, because we are all humans and we're not machines. We're not meant to work 24/7. That's the basic structure of the incident handling team. Now, you might have noticed that I did not mention very popular network operations center. I mean, I'm very used to that concept, but there is no such thing. There is no need for a network operations center, because the alert for the incident is going directly to the SRE that is responsible for the product. That eliminates the middle layer, and that gives you the fastest possible reaction time to the incident. That's a good thing. I just mentioned alerts, and they are next crucial part in this whole thing. Now, alerts are very important, and in terms of incident, alerts need to be well defined. There needs to be a good reason to wake up at 4 a.m. or 3 a.m. or something. And good reason means that there was an actual outage that affected the customers. So imagine an alert, like in the middle of the night, and you're getting an alert that says CPU usage is high. Like, that doesn't give you anything. By the time you reach terminal, by the time you start debugging the issue, the application will have scaled up, or the load balancer would have taken the machine out of the rotation and customer wouldn't have felt anything at all. So it's important to alert on actual usability of your application, and we just defined that. We just defined that we have an SLO. We defined that SLO is what indicates whether our usability is broken or not. So we alert on SLOs. There are two types of alerts on SLOs. There is, imagine a situation, you're monitoring your SLO or your error budget for a month, and you burn through 50% of your available error budget within 2 minutes. Now that means that something is hard down, something is very broken, and there needs to be action taken immediately. There needs to be, wherever the SLO is originating from, the SLI, that needs to be investigated. And that's a good reason to wake up in the middle of the night. There is another type of waste of error budget that is very subtle, and it can be very hard to distinguish from the general noise that might be happening in a very large distributed systems. And those are called low burn alerts, and they are meant to monitor very subtle changes in the system that might have caused increase in errors. And those can be handled within business hours, and there's no need to panic or act very fast on them. All right, we covered the alerting, but alerting has its origins. There needs to be information that is coming to serve as a basis for alert, and when you are already handling the incident, you need a lot of information. So the information is coming from monitoring, and it is very important to have flexibility with the monitoring system. So as an engineer, when you are debugging some kind of issue, when you're handling an incident, you need to be able to filter out all the unnecessary information that you might have in the monitoring, or aggregate that in some kind of statistical analysis that might give you a hint on where the underlying issue might be. So it is big picture versus detail. So you need to be able to look at both of them at the same time if required. And it's important to have as much flexibility with your data that monitoring system is giving you as possible. That will help you immensely with debugging the issue. Now that the incident is handled, and we mentioned the live incident state document, which has been filled in constantly all this time, that document goes to serve as a basis for a postmortem. Postmortem is post-analysis of the situation, what happened, what actions were taken, and it is root cause analysis of the issue. We should not hold postmortem meetings for the sake of postmortem meetings. They should serve as a basis for future action. And the future action being an actual remedying of the problem, turning it into a pattern and applying it to similar other issues that might have a similar path for evolving the problem and a similar path for solving the problem. And it is also very useful for practicing and preparing for reacting to incidents and handling incidents in the future. Very crucial part in this whole process, in the incident handling, in the postmortem and the post-analysis of the issue, it is very important to not focus on a human part of this. Never ask who. It's always about what or when, why. The SRE work is blameless, and it is super important to not stress out the humans who are part of this equation, because when you are pointing a finger at someone, when someone is under stress, first of all, if you're going to point a finger to someone, they're not going to be in the room. And most probably they will not have any kind of motivation to collaborate or think or solve the problem. So never focus on a human part of this, always focus on what was the problem and how we solved it or how we could have solved it. So SRE work is blameless, like remember that part. And I think any kind of work should be that because we're all engineers, we're all humans, we make mistakes. It's important that we learn from them, we grow, and we fix them obviously, but we should not be dwelling on that. Our focus is creating something awesome, something new, never like who is to blame. And I would like to share some resources. You can ignore the last one. Obviously, the SRE book from Google is like the crucial part of this, but I would, I did not include brendangreg.com. Okay, so you can remember it from like listening. brendangreg.com is a website of an engineer who is used to be, until recently, a performance architect at Netflix. You can check out the Netflix blog. I'm pretty sure you'll find a bunch of stuff there that will mention that website. brendangreg.com is a goldmine for information for anyone who is interested in Linux in general, in BPF, or in any type of SRE related work. That man has a treasure trove of information there, so it's very cool. Yeah, and that was me. Thank you. I would, if you have any questions, please go ahead. Please.
Very good talk, thank you very much. My question is, how do you actually identify the severity of the incident? Like 3 o'clock at night, everybody woke up, and then, oh, sorry guys, it was a small incident, we can talk about this in the morning. Or what is the strategy to figure out to wake up, not everybody, I mean.
That's a good question. The responsibility in that case lies with the SRE who receives the alert, so the incident commander. They give the severity of this incident. And obviously, the #1 guide to how severe the incident is the usability of the service. So if users are not able to interact with the service, that means something needs to happen, something needs to be solved. That's how I would define it basically.
But this will be identified only after everybody woke up, right?
The first person to wake up would be incident commander, then that person would be assembling team based on the need for the incident.
Yeah, thank you very much. This was a trick. I didn't know that. So not everybody.
There is actually the SRE book that is here. There is actually an actual guideline for what constitutes as an incident, and there are more details there as to what actually should be defined as an incident. So it's a good place to explore for that question. Anybody else? I think someone over there went, but I don't know, I'm not sure.
David, thank you so much for quite interesting presentation. I want to give us. I have a question regarding. Sorry, what do you think? What is the best template in order to not make customer angry and to make it reliable? You know, is there some kind of suitable template for automatization these kind of rules?
Okay. There is no sort of hard-coded template, so to speak. I would say the good thing about the SRE is, even though it mimics a lot of DevOps culture elements, it is a specific implementation tried and used by a large organization, and it has all the patterns that you see in the SRE, they originate from actual practical problems that have been solved by it. So large organizations have nice patterns that you can implement in your smaller scale organization, for example, and those would be a good place to start exploring on what good practices you could be implementing in your workflow. Obviously, it is very company dependent. It depends on the company culture as well, how teams are organized. You can't force such a massive change instantly. So you can take bits of the best practices used by the large companies and integrate into your workflow and cater and customize that to your specific product. I would say that's how you could start exploring that.
Thank you.
First of all, thank you for your informative talk. And what would you recommend someone getting started in SRE? What's the things to do and things not to do? That would be interesting.
Well, that's an interesting question. First of all, I may sound very strict when I'm saying this, but there is no junior SRE or there is no junior DevOps, as a matter of fact. So you already have some kind of experience that you build upon, and you start filling in the missing pieces. If you come from a software development background, you start filling in the operational parts, and vice versa. If you're an ops person, you start filling in the software development part. One thing that a lot of people miss sometimes is the importance of the observability and monitoring parts. So both camps sometimes miss that. The software development and the ops parts miss how important it is to have very good observability into applications. So you build upon your existing experience and you start filling in the missing parts. You start learning how infrastructure works, you start learning how development works, you pick up a language and you get very familiar with it, you start coding, and that's how you would get started into SRE. That's how it would become a full-fledged SRE, so to speak. And you would definitely not be junior because your experience already matters very much, and the filling in missing parts will make you far more advanced engineer.
Thank you. Thank you. And another question. If someone is already a DevOps engineer, I think that SRE and DevOps are very familiar things, and what are the differences between them, and what do they do differently?
Good question. Well, the name speaks for itself. Right now, unfortunately, first of all, not all organizations get SRE and even DevOps right. They still have these silos, they still do this ops and support separately. So if your organization gets DevOps and if you are actually doing DevOps work, you have very little change remaining to transition into SRE. You just take part into development process more. So the crucial thing about this is, while DevOps engineers today in companies, they have their own department, so to speak, and they do their own thing, SREs, while they might have some kind of organizational department, while they're working, they are tightly integrated into the product teams. They are part of the developer camp and they work on that product together with the developers. That's very important. So that would be like the biggest change, looking at it from today's perspective. So you start working on the product alongside with developers, you start coding. Maybe initially you don't touch like business logic, but you start coding other stuff like infrastructure or cloud native related things, and you integrate into the development process tightly. And that would be a good transition to SRE, so to speak.
Thank you so much for your thought. That was very interesting. I have actually two questions to you. First question is, imagine when SRE engineer is getting incident. Usually with incident there are some runbooks and troubleshooting documents based on severity that the engineer can look on that documents and try to troubleshoot and resolve the incident. So my question is if there is no well documented troubleshooting documents or runbooks, what do you think is the problem from the EM side, like service owner side, that was not good documented, that engineer couldn't resolve the incident, and is that good practice to onboard microservice or services with well documented state? That was my first question. And the second question, what other tools except PagerDuty you know or you can suggest for alerting?
Okay. To answer the first question, the playbooks originate, they can be originated from the incident document and how the incident was handled previously. So I guess it would be impossible to cover all possible scenarios, so there might be some incidents that never have precedent, and there's always first time for everything. So at that moment, for SRE engineer, it is very much like allowed and a very common practice to call in other engineers and also call in the development team that worked on the service. And that incident will, of course, serve as a basis for a future playbook that will be used by future engineers for the similar incident. As for alerting tools, unfortunately, no. I'm not really familiar with too many alerting tools. I guess you could use Alert Manager alongside with Prometheus to integrate alerts with a bunch of other services like Slack or phone, SMS, and so on and so forth.
Thanks.
Sure.
Hello, my name is Tigran. I'm from Data Art. I have a question regarding the automation of, like, for example, you have a database which is failed. Why we not automate the database to restore it, for example, to another cloud or to another AZ, or let's say on-premise, or we have some code problem? Why we are not automated to like restore the old version? Why we involve the SRE? Like SRE should receive some alert of error and solve the problem. Why we not automate the whole process to restore the infrastructure or the site?
If you already have a process that handles this automatically, you don't need to involve SRE at 4 a.m. You can take a look at the incident in a business hours. If something cannot be handled automatically, that's when you involve human element. And that's the whole idea of SRE. Have machine do the work that humans would not be as efficient and as precise doing.
But you can know in advance all errors and all problems and automate, like, for example, recently we have some error with AWS access and secret keys, which is like, if you try to access like it 5 times, then it blocked for 5 minutes. Why we don't have the second AWS access and secret keys? If the first one will fail, we will use the second one. And like configure your whole environment with redundancy. Like all stuff will be with redundancy.
That's, I don't know how to answer that, to be honest. That's very organization dependent. I mean, why not? But that depends on the organization, that depends on the budget, I suppose. So it's not easy to have a living duplicate of your environment all the time. That costs a ton of money. So that would be one of the issues why you wouldn't be doing that. Ideally, though, yes, you could do that, obviously, but we don't live in a world with infinite budget and infinite capability. So that would be kind of #1 reason why you might not be doing that.
Thank you.
Thank you. Thank you very much.
Our next speaker is Arman, so we will get ready in 2 minutes, and yeah, that's it.
Okay, So, hello everyone. So my name is Arman. I am from Data Art Armenia. I'm happy to see you all here. So thank you organizers for this chance. So today I am going to talk about AWS organization, and we'll try to share my experience with AWS organization. We'll try to talk about some interesting parts of AWS organization, and we'll try to talk also about things that you can find in documentation. So let's start. So, sorry. Okay, first of all, I want to give some description about the AWS organization, if you don't mind or don't know. So, AWS organization is an account management system that enables us to manage our AWS accounts and organize them in one place to easily manage and to have some consolidated billing on it. So with AWS organization, you can do a lot of things. So AWS is integrated with AWS organization, a lot of services, different services, which whom you can manage and configure your accounts. So basically, yeah, that's the AWS organization. And here I want to say how it can help us to solve our problems. So the first is centrally manage and govern our environment as we grow and scale our AWS resources. Programmatically create new AWS account and allocate resources group accounts to organize our workloads. Apply policies to accounts or groups for governance. Simplify billing by using single payment methods for all our accounts. So yes, this good things. This is what I will try to describe and show you. But before that, let's think about single AWS account. What kind of problems we may face, we may see when running all the things in a single AWS account. So the first thing that is painful for everyone is running multiple resources in a single account. So imagine the environment when you have everything in a single account. So let's say you have different environments in one account, you have a lot of resources in one account, and in some point, even you will lost around all these resources, so it will be very hard to understand which resources belongs to which service. Of course, you can implement naming conventions, you can have a tags, but again, so it's hard to understand. The second thing is quotas and API request rate limits. So we all know that AWS has quotas on resources and API request rate limits. And when you are running all your resources in a single account, or your applications and environments in a single account, you will reach these quotas and limits very soon, which is not good, yes. So the third thing is a billing. So this is also one important thing. So imagine cases when we have an application. So this is something new which we are trying to discover, which we are trying to understand. Is it okay to use or not? Is it worthy? So and sometime business owners is coming and asking the question. So we want to understand: is this worthy or not? Should we continue to use it or not? And here, if we are running everything in a single account, it will become very hard to understand how much exactly costs this application or this service. So we need to dig into the service, find all the resources that this application is using, and try to calculate some cost for us to say, okay, this application will cost this price, and that's it. So yeah, next thing is a security, and here also we will have some problems if we will run everything in a single account. So yeah, so we can solve the problems, security problems. We can have set up some isolation, we can set up a security groups, we can set up a different subnet, different VPCs, firewalls and things like that. But again, so it's hard to do. We need to do a lot of configuration, we need to do complex setup and things like that. Access, about access, this is also a very interesting thing. So if you have running all the environment in a single account, and for example, you want your developers to be able to access staging or development environment, if you're running everything in a single account, you need to give access to all accounts, and at the same time, this guy who wants access to development, he will be able to access also production configurations, which is not good. Again, here you can set up some restriction, you can set up roles, you can set up a lot of security guides to not allow access to the resources on the production, but again, it's also complex, so you need to do this configuration. Scaling is also maybe a problem, so this is another part, so which is a problem when we are running everything in a single account. And the last thing is auditing. Again, so if you are running everything in a single account, and if you are going to do some auditing, for example, you need to meet some compliance. And if you are running everything in a single account, compliance team may say, okay, so you need to pass all your resources to the compliance, which is not a good, so, and we want to pass everything, so we have 2 or 3 services, which is okay to pass. So, and here, to solve all this problem, AWS organization can help us to try to solve all these problems. So with AWS organization, we can easily group workloads based on business purposes and ownership. So we can easily understand the applications. We can easily understand the purpose of the applications. We can group the resources based on their business logic, based on team, based on, I don't know, whatever we want. And we can gather these applications in one account, and that's it. So we don't need to do anything else. So apply distinct security controls by environments. So if you are decoupling your applications in a way, so they have the same business logic, they have the same teams are working on this application, so you easily can decouple the application into different accounts, and and you will have a distinct security control, because you don't need to isolate the application. It's by default, it's out of the box, already isolated, and there is no need to set up anything else. Constrained access to sensitive data. This is another good point. Yeah, again, if you are dropping your applications into the different accounts, so it's very easy to organize access to sensitive data. So you can have the list usually and allow this or that users to access production information, and don't allow others to access to that information. Promote innovation and agility. This is another good point, because during the development process, there is some cases when developers or engineers is coming with good ideas, and you want to understand if this is a good thing or bad, so you won't say, no, we are not going to use immediately, but you want to allow this engineer to do some POC, to do research, to set up some initial thing, and then at the end you can understand, are you going to use it or not? And here with the multiple organization accounts, you can do that. So you can have an account for that, so the engineer can do everything that he wants. Then you can suspend account, delete account, and drop away from organization. Limit scope of impact from adverse events. So this is also a very important part. So in some cases, you may have an applications which are broken, which becomes broken in some point, or maybe there is some malicious software which is harmed your application, and because by default you are doing the isolation, you have 2 different accounts for your applications. These broken application will not harm another part or other applications in your environment. Support multiple IT operations modes. Again, so if you have multiple IT operations modes, you can have different accounts for this operations, and easily do whatever you want. So manage costs. Again, because you have different accounts for your applications, and basically each application are running on its own application. So you can easily manage the cost, you can easily understand the cost of the application, you can easily, I don't know, check the cost, manage bills. So, and because AWS organization is providing ability for having a consolidated billing, so you can have a one master payer account, you can connect all the accounts to this master payer account and pay from this account. Yeah, and last thing, so distribute AWS service quotas and API request rate limits. Again, so because you are running your environment under different accounts, and these request rate limits and API request rate limits are tied to accounts, so you don't need to care about this limit, or even you will reach those limits, I don't know, very long time. Okay, so now let's before showing you how to set up this organization, so I want to make familiar all of you with the most common terms. So the first is organization unit. Basically, the organization unit is a container of our accounts. The main organization unit is a root account. Is a root organization unit, and you can create your own organization units. You can have organization unit hierarchy, and then you can put your accounts under these organization units, and even you can apply security policies to these organization units, and these policies will drop down to other organization units and to accounts. Service control policies is basically, this is the policies that we can create to restrict and manage the security over our organization. So we can create security policy. For example, we can not allow people to create resources without a tag. So we can set up a secure service control policy, apply to organization unit, and it will not allow to engineers to create resources without a tag. Control tower is basically another AWS resource which provides the easiest way to set up and govern a secure multi-account AWS organization, AWS environment, which calls landing zone. Yeah, so landing zone is it helps us to more quickly set up a secure multi-account AWS environment. Account vending machine is a part of is a key function of our landing zone, because here we can, from here we can create our accounts. We can predefine some configurations. We can even predefine a configuration for VPCs. I don't know, everything. And the last part is AWS config. So the AWS config is one of the main components of our AWS organization, control tower, basically. Because why? Because with AWS control tower, we can easily govern, manage, and make sure all our accounts and all resources under these accounts have the prepared configuration and prepare in the way that we want. So let's say it's making sure so we don't have any uncompliant resources. So we can, with the AWS config, it's very easy to pass any, let's say, audits. Like if you have a PCI DSS to pass or HIPAA compliance want to pass, you can even enable the role in the config, and it will check all your organization for compliance, and will do continuous checks for all our resources, so you will be compliant. It has implemented SNS, SQS services to have the notification, to inform about the changes and things like that. Okay, let's see what will prepare control tower if we will run AWS. We will try to create a AWS organization through the control tower. So it will prepare AWS landing zone, multi-account management using AWS organization, Identity and federated access management using AWS SSO. So Control Tower will prepare for us AWS SSO, so it will be already configured. All our accounts will be integrated with the SSO. Centralized log archive using AWS Control Tower and AWS config. Cross-account audit access using AWS SSO and AWS IAM. End user account provisioning through AWS Service Catalog. So Service Catalog is a part of account vending machine again. Centralized monitoring and notification using Amazon CloudWatch and Amazon SNS. A native cloud directory which pre-configured groups and SSO accounts. 20 preventive guide rails to enforce policies and 2 detective guide rails to detect configuration violation. Basically, these guide rails are the rules, so which are making sure our resources have the proper configuration, have the configuration that we want. Okay, let's see what we will have if we will create an AWS organization through the Control Tower. Basically, we will have a master account with a designation of our existing accounts. So we should have one account. We should log in into this account, start creating Control Tower. Control Tower will create a master account, which will become our main account. With the main account, it will create a master Control Tower, AWS Service Catalog, AWS organization with the 2 default organization units. Basically, so it can be a security organization unit and custom organization unit. In my case, I have decided to create Sandbox. AWS single sign-on with integrated AWS as a directory. Again, under security organization unit, we will have 2 accounts, log archive account and audit account with all the things that we need to configure auditing and logging, and Sandbox accounts, in my case, to set up that that account for testing and doing some POCs. So here I want to give some ideas how we can create how we can organize our accounts and organization units. So to understand how we should organize our organization, we should create accounts and organization units, we should understand the business logic. We should understand the purpose of certain accounts, so we should gather the application that have the same purpose into the same account. We should understand the business logic. We should differentiate business units or product teams using different processes. And based on this, we should start creating our organization units and accounts. So here is some basic example how we should create our organization. At the top of the organization is a root organization unit. All other organization units are going under this organization unit. So first one is a security organization unit. I already said, so all the accounts, all the stuff that is going related to logging and auditing will go under this account. We can have an infrastructure organization unit and all the accounts that are related to setting up shared environment, shared infrastructure for our AWS environment. It can be a shared networking account, it can be a shared databases, it can be a shared SQS queues, it can be even everything. So we can put everything under the infrastructure organization unit. Third one is the workloads, and here we should put all our workloads or our services and stuff like that. And as you can see, I have created on each of these 3 organization units, I have created another organization, prod and SDLC. So as you can understand from the name, so prod organization unit for prod accounts, for prod resources, and SDLC for development. And with this way, we can organize development in SDLC part. And the last organization unit is a Sandbox, and as I said, we should use this organization unit for, we can provide accounts under this organization units for testing, for POCing, for stuff like that, and we can have here restricted roles, restricted quotas, restricted configuration, so And then we can give this to developers, engineers. They can do whatever we want. You know, we can take an account and test out the Terraform configuration under this account. Okay, so everything is good, everything is fine. So now I want to share some information about the cost. AWS Control Tower itself will not cost anything. It's free, so you can create AWS Control Tower. You can create your landing zone. You will not be paid for that. So, but you will be paid for the resources that AWS Control Tower is going to create. So it's going to create Amazon S3 buckets for storing the logging and trace like that. Control Watch, AWS config to govern all our accounts and resources. AWS CloudTrail, AWS Service Catalog, AWS SNS. So for all of these services, we should pay. And here is some example. If after creating the landing zone, we will create 25 new accounts, and we'll run 15 resources on each of these accounts, and we will have 3 regions, and all these resources will go to these 3 regions. And then we will enable 5 strongly recommended preventive guardrails. Each of our resources undergoes 50 configuration state changes per month. But let's be honest, so we are not going to, so changes on our environment will be more than 50 times. And if we will reduce to 2,000 rule evaluation per month, so we'll be billed approximately for $15,625 for AWS config to record 6,875 configuration item changes. Each per configuration item changes is $0.003. $10 for AWS config to record 10,000 rule evaluation. Account Factory will provision 25 new accounts at the rate of $2 per 100,000 management events. Charge for resources should get config, I don't know, catalog, SNS, CloudWatch, so the cost will be approximately $16,625. Actually, this is not a big price, so yes, it's good, but in the real world, everything is different. So here is another example. So what if we may lead to if we run ephemeral workloads in AWS account? So with the ephemeral workloads, the picture will be different. Why? Because AWS config will charge us for each configuration item changes. So configuration item change means when you are changing the state or the configuration of your resource, no matter what resource is in. So basically, ephemeral devices are the devices that, for example, EC2 spot instances, Amazon EMR, AWS Autoscaling, all these resources are ephemeral devices, resources, and they are changing the state frequently. So, and here we will see a different picture. So the price will be different, and the difference will be the big. So for example, I want to ask you an example that we had with our project. So we have started using we decided to use AWS Control Tower because the environment has some compliance, and we want to have we decided to have some continuous compliance. And when we started our resources and when we started using AWS Control Tower, we know that in the modern software development lifecycle, we are trying to do changes frequently, giving releases frequently. So we have automated the process to do this release and things like that. And after 1 month, we get paid more than $10,000. So this is a really big amount of money. So you should be ready for that if you want to use Control Tower. Okay, but what we decided to do, so this is a big amount of money, and in some point, so I would say that that's more than $10,000. It's so 10,000 is just an example. It's a very big price. So what we decided to do, so we have sat together with the team and started thinking about what we can do to change this cost, what we can do to not pay that cost and have the same control on our environment. And here we have started thinking about, okay, so the control tower, AWS config. So yeah, an important thing. So most of the price is on a AWS config. So AWS config will charge that money. So and we started thinking about what we can do to avoid paying this money. The first thing that we thought is to disable the AWS config. But it is not possible if you are using AWS control tower, so you can't go and just click disable AWS config. It is not possible. So you need to avoid using AWS control tower at all. I hope we don't have anyone from AWS, yes? Okay, so what we decided to do. So we have created for us a list and we started thinking what we should do, manage ourselves to not use control tower but still have AWS organization. So we should be able to create AWS accounts. We should create the basic IAM roles. We should manage identity providers ourselves, set up cloud trace, centralized auditing, set up CloudWatch for logging, set up SCPs, run default resourcing in new account, and have continuous auditing and compliance. So here I just want to give some information, example, what we have started to manage ourselves. So organization information management. So resources creation, editing, deleting through the Terraform code. Yeah, and as all said before me, so everything is going to continuous integration and to infrastructure as a code. We need to start manage everything through the let's say Terraform code and through the CI/CD pipelines, deliver all these changes to our environment. Another thing is account creation, organization unit creation through the Terraform code. Again, we can do that. We can set up Terraform code to create all these things through the organization, through Terraform. Change management, CI/CD pipelines, release management, documentation. We should have a process for change management, so we need to write everything, this stuff into documentation. We should have a release management documentation. We should have some place when we will write what we are going to release, when we are going to do a release, and who is going to be a lead of this release. Notify about changes in any environment. So as you remember, one of the functions of the AWS config is that it's notifying about any kind of changes on our resources. So we can set up our pipelines in the way to notify through the Slack or through the email about any change on our environment. We should have implemented a mechanism to grant console access. So yes, we should have some kind of identity and access management to allow and deny access to the console. We should avoid doing changes manually in our accounts. So yes, this is another part. So we can, because we are going to set up centralized cloud trail, we can monitor the cloud trail and find actions when someone is doing changes manually and trigger and send notification to channels. We should use static analysis security scanner for our Terraform code. Yes, this is another thing we have implemented. We have implemented a tool to analyze and scan our Terraform code for vulnerabilities. And we have integrated this tool directly into our CI/CD pipelines. So now if anyone has any security hole, he should fix this problem, and then he will be allowed to deploy the Terraform code. Okay, AWS organization and infrastructure management, as I said, so use Terraform to provision new accounts, always create resources from modules and keep tracking of configuration. For example, here I give the example of VPC, because we are going to have a lot of different accounts. In some point, it will be very hard to understand which configuration to track the changes and the information about our organization and accounts. And one of the things is a VPC. So we are here. We have a CIDR blocks, and we need to understand to make sure the CIDR blocks are not overwriting to each other, overlapping to each other. And we can, with the Terraform, we can have a list of these configurations. We can keep a tracking of the configuration. Create a module which will keep all information about all our accounts. So yes, we can have a module which will contain all the information about all other accounts. That can be a account ID, account name, account VPC configuration, account workspace configuration, Terraform workspace configuration, even more. So we can put there any kind of information that we want, and then use this information to spin up another resources in another account. US CI/CD, when doing changes in infra, each account should have its own runner with role to access account resources. So yes, but the important thing is this: we should make sure that dev runners should not be able to access to prod accounts and vice versa. So it should not be. We should make sure it's not doing it that way. Each account should keep its own Terraform state. So I would not say this should, but nice to have. So we can put each Terraform state on each account that we are going to configure. Use Terraform remote state data source to get resources information from other accounts. We can use this to access the state from another account, read the configuration, and set up resources on our existing current account. So one of the examples is we have a SQS queue in one account, in a account, and we want to access this resource through resource array or URL, so we can use Terraform data source to get that information and use on our current account to set up a resource to access this SQS. And we also can set up cross-account access YAM roles again, so this can be also defaulting. So when you're setting up our account through Terraform, then we can run a Terraform code to apply some basic IAM roles, integration, cross-account access, and things like that. And even with the AWS organization, it is very simple to do because you can create a condition and say, for example, all this resource can be accessible from all my organization unit. So you can put the organization unit ARN and have that configuration. Okay, now I have prepared some demo which I want to show you. Okay. Okay. So this is the process of setting up AWS Control Tower. So first of all, we need to open the resource. As I said, it's a resource, another resource of AWS. So, okay, here is the home region from where we are going to start govern our AWS account. We can enable region restrictions. Right now, I'm not going to do it. We can add another regions to govern from the organization. We are going to have two default organizational units, security and sandbox, so we can change this. We are going to set up usernames, email addresses for our accounts, audit. So as I said, you are going to have a centralized log management and trade management. We can set up buckets here. This is an overview, information about the roles and policies that the Control Tower is going to create. About policies, information about things. So we are going to understand, set up landing zone. Couple of our letters. Here is the interesting, so it may take almost more than 5 or 6 hours. We will have this, so we will have, it's already notifying about what we have by default. We have two organization units, t-shirt accounts, native cloud directory with pre-configured groups and shared single sign account, 20 preventive guidelines to enforce policy and detective guidelines to detect configuration violations. Okay, this is the structure of our organization. Here's the guide rails that we can apply to our account. Yeah, this is the single sign-on page. So from here we can log into our accounts. Here you can see the list of our accounts. landing zone configuration, region that we are governing right now, summary of configuration, and activities. So we can see. So now let's see how to create the organization unit. So right now I'm doing it through the console, but you can do this even through the Terraform. Here's the account ID, the policies that this account has by default. When you're creating the organization unit, it's not registering automatically, so you need to, what was happening? Sorry. You still need to register your account, your organization units to apply all this, guide rails and policies. It's also taking some time, then it's registering, everything is good. Here is the step when I said so we can put an information about all our accounts and organization into the Terraform file and manage and have something like account info module for all our accounts. Here we can have information about our organization units. From here we can take the information and set up, let's say, rules, cross-account access rules and things like that. Here is the process of creating AWS accounts, so we can use that information module to create a new account. Again, here's the accounts list, so from here we can keep a track of our accounts, dev accounts, prod accounts, either what organization unit we are going to create, and have some description. The information that we are going to have, apply, and here we already have accounts. So, but these accounts also should be enrolled to organization to apply this security guide rails and configurations. So, again, during all this process, you will get the emails about you have new account, you have to accept this account, you have to accept the roles, you have to accept SQS message queues that you are going to subscribe for getting information. Here's the config example. So important thing is this, on AWS config is going to be configured on each account, on each region. So if, let's say, if you have a 3 account and you have on this 3 account, you have 3 regions enabled, AWS config will be run on all these 3 regions and all the 3 accounts. So you will have 9 AWS config configured on each account. The associate that is going to manage policies and things like that. Identities, resources, names. This overview what we just created, but I don't want to show you this one more time. I just want you to show the building part. Sorry. This is organization, so we can create our organization directly from organization resource to not use the control tower. We will have the same thing, accounts, organization units, hierarchy. We can set our policies from here, apply to organization. Okay, here's the billing. So as you can see, I don't have anything in my account, but I already started paying for something. So we have a SQS configured. Sorry, S3 buckets, and here is the config configuration. It started billing us something. And here you can see prices per account. So you can list all our accounts. You can have your, per account, bills for each of these accounts. So you can understand, you need this account or you don't need these resources. You can disable, suspend, delete this account, delete the application. Again, config price. All my accounts integrated with a single sign-on. So Terraform code, let's go through the Terraform code one more time. So we have account info model with all the information that we need to set up our other resources. So for our case, we are storing here is information about VPC, about CIDRs, information about workspaces, information about notification channels. So it can be everything that you want to organize your accounts. Master account, organization information, some outputs. So from where we can get, so we can call this model, tick the output, and see the information. Account configuration. So we can put the accounts in this list and just Terraform apply, it will create all our resources. Yeah, here is the example of VPC configuration. So we have a locals with predefined configurations for all our VPCs. Same can be for anything you want. So why we did in this way? To not override the VPCs, because in some cases you would need the VPC peerings, and it's good to not override the IP addresses. And something think about CloudTrail configuration. So by default, yes, you will have the account, you will have the organization, but the CloudTrail will not do centralized logging and auditing. So you just need to set up it manually. You just need to get to audit account, create the CloudTrail, press to create the new CloudTrail, enable the CloudTrail, say this is going to be for entire organization. So I don't have any events here, so this is new, but here what I want to share is this. So ES3 bucket will be organized in this way, so we will have a list of all our accounts. So, and from here we can just check, so if anything new is getting to this, any one of these, let's say folders, we can check the event source and understand if this is a manual change or if this is done through the Terraform. If it's a manual change, then we can notify and say this user changes under this account. Yeah, this is Ant, and if you have any questions, please let me know. Thank you.
Hello.
Hello.
Thanks for the presentation. It was very interesting. I have actually two questions. One is about cost optimization, actually cost management. So do you have in your organization any defined cost control, cost management process in the accounts which could be applied to any services you use?
So actually, we have something like that. We have enabled cost alerting. We are getting alerted about any anomalies in the cost, and it helped us to find very interesting anomalies during the configuration. So, and another way of managing our cost, we are using a cost explorer, and we are doing configuration of the tags. So we are making sure all the resources that we are going to have the tags with defined parameters, like who is the creator, which team is going to manage the resources, what kind of application are using these resources. And at the end, in the Cost Explorer, if you have the organization, you can get to the Cost Explorer, enable it, it will gather all information from all your accounts, and you can just filter through the tags and see cost of all your resources. From there, you can understand, for example, yes, so what kind of anomaly you have. So let's say you have paid 1 month. So one example here is this. So we are using the transit gateway to create a global network in our AWS organization. And one day we had a 10-time cost change because AWS decided to enable the global network accelerator. It started before it started free, they started billing with us, so we saw that, we immediately turned it off and everything was good.
Okay, thank you. And the second part of my question is about the vulnerability check. That you mentioned that you're running some software before doing CI/CD deployment. So is it a native written software, or do you use any like publicly available?
Yeah, thank you for the question. So yeah, these tools, as Anton mentioned, we are using DevSec for these purposes, but there are a lot of other tools. So why we choose a DevSec? So because basically in that time when we started using where we decided to use this kind of tool, only the DevSec is able to understand the advanced Terraform configuration like for each loops, count, conditions. All other tools are not able to understand this. So we are using Terraform DevSec to check all the Terraform configuration because deployment, they have a predefined security checks, so they are applying, and again, you can write your own. So for example, we have created roles to check all resources for default tags. If the resources does not have these default tags, you will be alerted, your pipeline will be failed, you need to go and set up everything again.
And what do you use for this notification alerting path? Like if the check is not passed, what services work?
So actually, we are using Slack to send our notifications. So pipelines directly sending the notification to the Slack channel. But we're also using Grafana and PagerDuty. So PagerDuty is integrated with the ELK stack. So like those times when some log is coming with the pattern, PagerDuty is alerting, and the same for Grafana. If something is happening at the resources, Grafana is alerting.
Okay, thanks a lot.
I have a question. So you said that a control tower was expensive and you decided to drop it. Very good. There are no AWS employees here, so I understand that. But what if people actually start using control tower and at some point they want to migrate away? Is there a way to, let's say, to delete it and re-implement resources which were created by control tower? Because if, as I understand, if I delete organization, then I delete pretty much everything, including all my VPCs.
So actually how we did this, we had a call with AWS support and started discussing with them how to disable this control tower without having this big pain. I can't answer to this question for sure because I'm not one who contacted with AWS and started this process. But yes, it can be a big headache. But the interesting thing is this: before the control tower, we already implemented all this stuff. So we already have the CI/CD pipelines. We already have the controls account. We are doing all this stuff through the Terraform, and we just decided if we are doing all these things and if we have all this control, if our audit is okay what we are doing and they don't need this config, then let's think about disabling. So as I remember, as I know, you can. Somehow it's possible to disable control tower itself, but I'm not sure. But so this needs to be. But what I'm sure, so we had a discussion with AWS and asked them to disable some parts for us. So they started arguing, so we can help to optimize this course and things like that. We said we don't want, so just disable it, and we are going to manage all this stuff by ourselves.
So this should be a very important decision when company takes early on. Right.
Yeah. So, and the important thing is to implement all the stuff that you and Nana said before on early stages. So when you are planning to implement and when you are starting to design the infrastructure, so you need to implement all the common patterns. You need to start managing your infrastructure through the pipelines, implement some GitOps to, for example, to run the deployments on any environment through the CI/CD, through the SVNs, so you are doing changes, pushing pipeline starting, going to deployment, into development, going to do some changes, test, then to review environment or staging environment, doing the test, to closer to production, and then deployment goes to production. But before going to production, you should have some process of release process, when you are putting all the documentation, all the tickets, writing, having the owners, who is a code owner, who is a release owner, you are getting approval, and then you should go, you are going to development. We go even further, we have developed our chatbot, who is doing this configuration for ourselves. So we are calling this Slack bot. It's opening questionnaire. We are filling the questions and it's creating the document, release document for us. We are just saying, okay, good, who can approve this? And then we are ready to release.
Thank you very much.
Thank you too.
Hi.
Hi.
Hi. Thanks for the presentation. Very interesting. I was wondering if you have any experience with SSO and tips or tricks or best practices that you might can share with us.
No, SSO is SSO, so I don't have anything special here. So currently we are using Okta as a single sign-on service. Yeah, we are integrating all our accounts through the Okta, and again we have a chat bot who is granting access to the user. So if someone wants access to any of the account, he should call the bot, should fill the information about what account he wants to access and the information about why he wants to access this account. Then this bot is taking the user email, adding the role for this user in Okta, and then you will see then you are seeing this account application in your board. So then you're clicking and getting to the account. But we have implemented timeout, so after some time it will be deleted again. Thank you.
Thank you.
Arman, sorry, I have another question. I didn't get the point difference between control tower and landing zone. I mean, what exactly they're doing? I didn't get the point.
So actually, control tower is a resource of AWS who is creating landing zone.
So they cannot be separate without each other, yes?
No, there is no separation. So it's a service resource who is creating the landing zone. So we are calling this landing zone because it has all the security and guide rails out of the box. So it's some place.
So the resource that we are creating through control tower, it's like a destination will be parked in the landing zone, yes?
Yeah, so when you are running control tower, it's creating a landing zone. It's creating this environment with all these guide rails and configurations by default that we can apply to our account.
And yes, another question regarding the billing, which you mentioned, correct me if I'm wrong, it means that all the accounts that we are adding to here, they will getting such kind of a consolidating billing, yes?
Yes. Yes.
So it's possible, yes? For example, we can remove or add some kind of so-called members or users.
Yeah, so you can add an existing account, but when you are deleting account from the organization, you should fill the correct payment information under that account. So the AWS can bill for that account. So if you are saying, okay, I want to remove this account from my organization, then you need to log into this organization through the root user, fill the payment method information, and then you can suspend the account. After 90 days, AWS will automatically charge you and will delete the account.
What about if, can the account be charged separately, for example?
Sorry?
I mean, the account which is already a member of the organization, can he be charged separately, or he will be charged?
So if you are not enabling consolidated billing, then your account will be charged separately, but what the purpose?
Okay, thank you so much.
Okay. Okay, thank you. Thank you very much.
So now we have Dimitri with business continuity and disaster recovery. So we will be back in 2 minutes.
Yeah, colleagues, everyone. I'll try not to overload all of you. I understand it's a bit late. Let's talk about this topic a bit. So let's continue with setup of AWS, kind of a short AWS advertisement. This topic, reliability and disaster recovery, well, from my perspective, it's a crucial point for all systems. I do understand that for the moment, it's a very limited list of the companies are even trying to implement the real disaster recovery, which works, which is tested. So let's try to discuss this. So briefly about me, hi colleagues one more time, I'm Dmitry Bukhtiarov, I'm here representing EPAM Systems. almost all my career, I'm working closely with different clouds, mostly focused on AWS. So this particular pattern for sure can be extended for any clouds. With this example, I'm talking about AWS, as you might see, but again, all these patterns could be used for any clouds, for any public cloud. All right. A couple of words before we'll jump deeply into the disaster recovery, business continuity, etc. A couple of words about the whole idea. Topics I already heard from almost all our speakers. And this basically framework I'd like to point to all of you. I just don't want to deep dive into all of these concepts, just very briefly. So AWS has a special concept, let's say a framework, calls well-architectured, AWS well-architectured framework, which contains at the moment 6 pillars. Pillar we would like to talk deeply is the reliability pillar, but briefly about all of them. So operational excellence. So in general, I would say, guys, if you would like to 100% be sure that your solution works as expected, configured as expected, contains and follows all the best practices solution should follow, you may reach to this concept with these 6 pillars to try to assess your solution and try to understand and to see the gaps and try to fix these gaps. So these 6 pillars: operation excellence, security, reliability, performance efficiency, cost optimization, and sustainability. So operation excellence is mostly focused on the patterns that your solution should be monitored. Your solution should follow different patterns of automation, like paradigm of infrastructure as code, etc. Well, I suppose that, for example, security and cost efficiency is more or less clear what is they about. So reliability pillar we would talk a bit deeply. So performance efficiency is mostly used to analyze that performance of your solution and your solution works from the performance perspective as expected, and the same stuff is for sustainability. So each of the pillar has its own design principles. And as I said, here we're talking about reliability pillar, and topic that we would like to discuss is mostly focused on the first 2 design principles for reliability pillar is automatically failure recovery and test recovery procedures. So for sure we are targeting on the automatically failure recovery. Here is just an example what may happen if your solution goes down. Just a couple of numbers that just take a look, guys, that we have it's kind of a problem statement we would like to work with. You see that company with the revenue of the 100 million would lose around $175 during a 24 hours of downtime. So I suppose it's clear to everyone it's a big issue. Moreover, probably if you guys are working closely with AWS, you've heard what's happened when it was 2 days ago, as far as I remember correctly, when one of the United States regions in Oregon, only one service basically went down. It was API gateway, but under the hood, it touches 53 plus services which were done basically. So first of all, we have to understand, because as I said, I don't want to deep dive into the business process here, but just in general how it looks like. So each company has a business continuity plan, which describes a different kind of scenarios which may fail your business and steps to recover this. And one of the steps is related to IT infrastructure for sure, and where our disaster recovery plan came in game. So first of all, we have clearly understand what is the disaster recovery for, what is disaster first for us. So what does it mean, right? So here it could be different kind of scenarios, but first, let's say from which point we have to start to design our disaster recovery plan is to clearly understand what is the disaster recovery for us. What does it mean? If we're talking about best practices, we have to follow, at least the very first of them is availability. And idea of this slide is to understand that high availability and disaster recovery are different things. They are probably look like and follow kind of same scenarios, but they are responsible for different stuff. For sure, we must have, let's say, high availability pattern enabled on the infrastructure. It would be great if we have fault tolerance pattern enabled. Disaster recovery, I wouldn't even say it's optional, but it definitely makes sense at least to think about. I would say that disaster recovery appears in time when availability, let's say high availability is not available. So let's say when high availability is not available. Basically, first let's quickly remember what high availability is, right? In case we're talking about AWS. So AWS says that we have to keep our infrastructure for at least 2 different availability zones inside of the one region. So what will happen, right, if all these availability zones will not be available? It means that all the region is not available. This is basically where disaster recovery starts. We already talked about today different KPIs. So for this particular scenario, for this particular solution, we have to keep in mind basically two main KPIs. First, it's a RPO, and second is RTO. Imagine that we have a disaster, right? And we have a, let me explain what is that. So first RPO, it's a recovery point objective. That's basically a accepted, let's say minimal accepted delay between the last captured data and our disaster. And disaster and recovery time objective, it's basically a minimal required downtime until our service will become operational again. In general, I would say how we should build our disaster recovery plan is to first, as I said, clearly understand what are the business risks and how to mitigate these risks. Next is we should clearly understand RPO and RTO. These basically two KPIs have to be accepted by business, by client. Creation of our infrastructure, disaster recovery plan for sure should be on paper, and last step, I will point on this step probably multiple times on this, but this plan must be tested on a regular basis. A couple of technical stuff here. So in general, we can, let's say, split technical implementation of the disaster recovery on two scenarios. First scenario is active-passive, and second is active-active. From left to the right, you will see that we are improving RTO and RTO from hours to even real time, right? But in the same time, cost would be increased from, let's say, cheapest solution to the, I don't know, X2, X3 from the original cost. A couple of, let's say, official examples just to understand what are the differences between these solutions. And in the end, one real example from one of my pre-sales when the real client works with this real solution. So I would say, just a second, well, as I said, I don't want to overload you guys with these schemas. Just brief understanding of the concept. So for sure, if we're talking about this schema, please keep this schema in mind. This can be applied for almost all the patterns we can use in the cloud, like VM-based infrastructure, container-based infrastructure, serverless, IoT, whatever. This particular example, like backup and restore, what is this about, right? We have a couple of services which are running in one region, and we would like to have a replica of this data of another region. Purpose, we understand, just to keep the backup of this data in the region which potentially could be our disaster recovery region. For sure, it can be done different ways. For example, I don't know, EC2 instances and EBS volumes can be backed up and shared to the region with one way. RDS, pretty same stuff with cross-region backup. What I probably try to summarize there, like AWS backup, for example, is the right choice here. Under the hood, basically, this service works and calls the same API as different services, for example, like EC2 or RDS, right? But you will have a centralized place where you can collect all your backups and see all your data and reports. Again, I will time to time jump back to this slide because we have to understand, right? Our RPO, RTO here is hours. Is it acceptable for our case? Probably yes, probably not, and it has to be discussed with the business and with the client. One of the newest services which are available in AWS, Elastic Disaster Recovery Service, which can be used for purpose when you run your infrastructure somewhere on-prem, but you would like to have a replica of your data in the cloud. How it works under the hood, it uses replication agent, and you can replicate your data for VM-based infrastructure or inside of the database. So I just put this slide, the second slide after backup and restore. So from my perspective, it is more or less the same setup. More interesting and let's say, the best disaster recovery plan, let's say it's you're trying to find a mix between the cost and your RPO RTO. So scenario with Pilot Lite and WARM Standby looks more or less the same. Idea is you already have on this particular example, see what's going on. We have a bunch of services which are running inside of the live region, and we have, let's say, partially prepared infrastructure in disaster recovery region. Crucial point here is the database. So for sure, if we are talking about stateful or stateless services, that's very good if you have a, let's say, stateless service, right? But if our service is stateful, it's very important and very crucial stuff to have a data available in the disaster recovery region. So on this example, Aurora database is used and asynchronous cross-region replication to the disaster recovery data. I would point probably here is it's important as well to take a backups here. Why? Because in the live region, something may corrupt your data, and corrupted data will be replicated to the disaster recovery database, which affect your disaster recovery for sure. In case it will happen, you can restore from your backup. WARM Standby is, as I said, looks pretty much the same, but compared to the previous slide, it has already prepared, let's say, minimal count of your infrastructure, which is ready to pick up your real data. So you don't need to wait. You don't need to wait a lot until the first traffic comes in. And finally, the most interesting, the most trickiest solution is to have a active. I just get back to one thing which I forgot to mention, which sits. All right. Talk about what's going on the switch. We should have a place. Where we do a switch between live region and disaster recovery region. And we are talking about, on these particular examples, we're talking about Route 53, which is DNS service inside of AWS. For sure, any other DNS can be used outside of AWS. This really doesn't matter. What is important here is to use AWS approach in general, a DNS approach in general. So if we're talking about AWS, we can use different set of scenarios inside of Route 53. So for example, we can use policies. We can use weight-based policy when we can change the weight of the traffic we do have. So for example, we can forward all traffic, we can send all the traffic to the live region with the weight 1 and send nothing to the region, to the disaster recovery region, and vice versa in case we have to change it. So getting back to this active-active solution, So you see what's going on. So we basically have 2 regions or more enabled to receive the live traffic. So let's say we have a kind of a balancer which balances traffic between different regions. For sure, we can use geographic-based policies, whatever. The crucial part here, in case one region goes down, the second region takes all the traffic without any downtime. That's an idea. What is the advantage is pretty clear. What is disadvantage? For sure, it's a cost of the solution first, and trickiness of the implementation that's second. Because complexity, we can understand that we have to do this, we have to automate this, we have to maintain this. And as I said, one quick example from the real project, from one of the pre-sale cases. And interesting thing here is, you understand all the concept you have to follow. You know the list of patterns you have to follow. But fortunately or unfortunately, reality and documentation is a bit different things. And we have to adapt our vision. We have to adapt our vision anyway. So client has a set of, that's very simple and very, very, very high level architecture. It contains much, much more. Client has the architecture, infrastructure, which is created inside one of the region and which follows some interesting patterns. For example, one service which probably you don't even heard about, it's a Gartner. It's one of the million different services, how you can spin up a Kubernetes cluster inside of the cloud. And Argo CD, which is used for GitOps. So I already heard that we understand what GitOps is, which is good. What is the interesting stuff here is, for example, a client used Aurora database, and what is the idea which came in my mind first is to just have an asynchronous cross-region replication with the database available in disaster recovery region, which became primary in case of disaster. That's clear. But during the real implementation, I just found that client uses 2 different types of Aurora database. Let's say, hosted database and serverless type. And during, let's say, in the time when I did this solution, unfortunately, serverless solution does not support cross-region replication, only backup-based solution. And by the way, at the moment, it is possible. So you can organize with the Aurora database, you can organize cross-region replication with serverless or with hosted database. That's one of the example. And second example is with DynamoDB. So client used HashiCorp Vault. So I suppose all of you knows what is that. Self-hosted HashiCorp Vault solution with interesting backend. So client used DynamoDB as the backend for the solution. And for sure, what you should do is to create your, because DynamoDB supports master-master replication, you can do that, but unfortunately it won't work for HashiCorp Vault, because HashiCorp Vault won't work with 2 masters simultaneously. And again, you have to adapt your solution instead of use probably best practice you know to the reality you have to implement this. Getting back to the real numbers, to be honest, I don't remember. But in general, the creation of the disaster recovery region took around 15 minutes or so. So in 15 minutes, we can switch to the absolutely stable solution which is available in separate region. Two topics. First is the so you have to be notified that disaster happened as quickly as possible, right? And for sure, here we're talking about monitoring, logging, whatever. So it's a very crucial point that you have a metrics or numbers that can help you to understand that disaster happened. And also important thing is the testing. Because disaster recovery plan, which is just on the paper and which is not tested on a regular basis, it means that you do not have disaster recovery in place. Because trust me that in case of disaster, it won't work if it is not tested. You can be 100% sure, but you, I don't know, haven't read that AWS changed something, you haven't adopted this, so it won't work. Probably you are aware, well, we discussed here some interesting concepts, for example, from SRE. As far as I remember, one of the patterns it is described inside of the SRE model is the house monkey. So house monkey is a special process which automatically breaks something, let's say, on your behalf. So it's just, it can just terminate one of your instance or a set of pods inside of the cluster or I don't know, just a database, etc. My only concern here, and I would say I'm still keep this question as open to me, and not sure that I really know the correct answer on this question is what to do with production. Because even we do the tests, right? How can we 100% sure the disaster recovery works if we don't test it on production? So I don't know the correct answer on this question. So from my perspective, it has to be tested on production, but let's try to discuss it if you have an answer on this question. Trying to summarize and close this discussion. So clients are responsible for the availability of their infrastructure. It's highly important that you have a business continuity and disaster recovery plan based on the numbers you agreed on the beginning, like RPO and RTO. You must be notified in case of issues as quickly as possible. And ensure that you run your tests of your disaster recovery plan on a regular basis. Colleagues, that's me. Thank you very much.
Hi.
Hello.
Hello. Thank you for the presentation. So I have a couple of questions about the topics. First of all is about well-architected environment or infrastructure. Do you know if AWS has a kind of method or certification or something that will let a person or a team to be recognized as a team or person who can build well-architected environment? Like you can do it, but AWS also recognizes that you are able to do that.
Okay, so I would say, well, as far as I remember correctly, each person who is certified like a professional level of AWS architecture, like AWS certified professional cloud architect, it basically means that you now can assess your infrastructure for well-architected.
Okay, thank you. And the other question is about the disaster recovery part. So
yes, before going to the disaster recovery, so to implement that part, I think very important to have well-worked incident management part, like when something goes down.
Exactly.
Yeah,
exactly, yeah.
how you should know and notify. So I wonder, in example of your organization, how do you deploy or implement incident management? Is it fully automated or partially?
Well, if we're talking about the example I showed on the previous slide, well, let's say there was a special team, right, who was responsible for the observability of the service. Let's put it on this way.
Yeah. So, can you expand that, or so you don't know any details? Like what I mean. So, from my experience, it's not everywhere it's deploying like fully automated. Like when some disaster happens, the bots and like pipelines are working, and the chats are creating, and the right people are involved into the places and start the disaster recovery process. And the other side, there is a method or that people receiving alerts and doing a lot of manual jobs to involve right people into right chats and start a right process.
All right, I got your question, thank you. So I would say it was working with the following way. There were, let's say, approved a couple of services we were needed to introduce for our services, that this service is now available for their system. And they now responsible for, let's say, any monitoring or any metric, let's say, for everything, what happens inside of this solution.
Okay, thank you.
Hello. Thank you for your presentation. You mentioned the question about testing the TR in production, and now I was thinking about something like canary deployment. Is it possible to test that TR for some percentage of the users? For example, in production, for 20% of users will be failed, and another 80 will work just as fine as used to be, and we will fail that just for testing how that would work.
I was thinking about exactly same what you said. One of the solutions, at least, that's what was in my mind.
Yeah, and have you tried something like that?
No. 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 But idea is, that's basically how I was thinking about this, yeah.
Or is there any tool to make that implementation of that thing, for example, to make the production in two parts and one part fail, another part no? I am thinking about it now, but I can't remember anything to use that in that case to make that production two parts and destroy one and not another. The basic way would be to make two environments, but that's too obvious.
That's basically what I said. So I don't know the correct answer here. So that's still open question to me.
Okay.
Yeah.
So thank you very much for your talk, but I think I can close this question, because what you asked is really about deployment strategy. It's not the disaster recovery itself. So in this case, we talk more about rollbacks from CI/CD perspective than disaster recovery itself. And here, what is important, and you also said that disaster recovery is something what we want to do on production, because this is production related, right? So that's how Chaos Monkey works. It works on production. It destroys something on production. And now, how we recover from this? This is the other point, right? For example, Brainly in Poland is doing that kind of things, right? At least they did in the past. So they are in multiple regions in AWS, almost all, and they just close something and they are watching what happened, right? And if there is a break in the service, they work on the way how to ensure that this service will be not broken. This is the test of disaster recovery, right? Because if real situation happen, it should work it should be implemented, right? Automatically restore the service. This is also about the self-healing infrastructure. Right?
Good, thank you. Thank you for the comment.
I also have one question. Thank you for presentation. So I want to ask a question about frequency of doing these tests. How many times to do these tests?
Yeah, I was thinking about this as well. So I would say with the solutions I did, I would say it has to be tested, let's say, 1 time in 3 months, like quarterly. That's my vision here.
So, what about consistency? I mean, in case of disaster, I think the biggest nightmare is to, I'm here. The biggest nightmare is to lose consistency and have some kind of split brain situation. So, how do you consider recovering from that? Because I think this is the hardest scenario to recover.
So that's basically what I said around a stateful or a stateless application, right? In case we have something which has state and we have to maintain this state, right? For sure, we must use managed service, which we believe supports this under the hood.
No more questions?
Then we can finish it.
Okay guys, so it's like very few people left till the end of the session. I think the day 1 was interesting. I hope that it was interesting. There were some intro speeches and there were really interesting technical deep dive speeches, including this one. Thank you for that. So tomorrow we'll start with workshops in the morning. We already announced them. Let's see how many people will register. Some of them don't want to register because it's Sunday morning, maybe, okay. They prefer to stay in the bed, but let's see. So we'll start keynote session from noon, so from around 12. We will make this announcement as well. This is also on our agenda. We'll post it again. So thank you for today. It was a great pleasure to see you.
So thank you guys, thank you everyone for coming. Also, I'd like to thanks for the sponsor, DataArt, Bank of Georgia, and obviously Ilia State University for hosting our conference. And actually, as Erekle already mentioned, we have like very interesting day for tomorrow. We have workshops, so we have to fill the form. Which is on our Facebook page, so just feel free to register and attend. So we will meet tomorrow. Thank you again.